A very good evening to all the ATAL participants. Today is the third day. We are going to discuss session 5 and session 6 today. Session 5 deals with the design of electrical vehicles, which is going to be handled by the expert member Dr. C.G. Saravanan, Professor, Annamalai University, Chidambaram, Department of Mechanical Engineering. Another session 6 is going to be handled by the renewable energy integration with electric mobility. Name of the industrial expert is Dr.T. Prabhu, Managing Director, Energy Solutions Ltd, Coimbatore. I hope all the ATAL participants are very interestingly and enthusiastically attending all the 6 days online FDP program. At this juncture, once again, we congratulate you for this ATAL event. Our expert is going to join within few minutes. General instructions, as you all know very well, 80% attendance is compulsory and 70% of marks is compulsory to qualify yourself to get the ATAL FDP certificate. Also, you have to process everything through the ATAL FDP portal. Coming to today's topic, that is design of electric vehicles. See, so far, in our country and as well as throughout the world, only IC engine driven vehicles are there. It may be having the petrol or diesel as a fuel, conventional fossil fuel. Now, electrical vehicles come into existence, and a lot of countries are very much interested to switch over to the normal conventional IC engines to the latest new electrical vehicle. The problem of electric vehicle is we have to charge the battery, and also while charging and recharging, there will be some pollutants to the atmosphere. That also we have to keep it in mind. So while designing an electric vehicle, all these parameters has to be considered, because battery, there are anode, cathode, and chemical is there. Through chemical reaction only the process is being completed, or either for charging or for decharging the forward or reverse electrical energy, or charging and decharging, the pollutants formation is inevitable. So why we are talking battery alone means, because in electrical vehicle, only the heart of the electrical vehicle is battery. So battery and the motor. So once the motor is energized by the battery, the vehicle moves from one place to another place. The thing is, what type of battery materials to be used, what are all the charging parameters, what are all the charging durations, and what is the stability of the battery, and what is the reliability of the battery. All these things has to be considered while designing the electric vehicle. So before going to have the basic parameters of electric vehicles, whether it is a two-wheeler or four-wheeler or the heavy vehicle, has to be keep it in mind. Then accordingly, what sort of battery has to be employed to get the desired output of the vehicle? That has to be the main parameter. So all these things have a greater impact in the design of the electric vehicles. So with this preamble, we will just have some preamble for the second session, that is nothing but the session 6 from 7:30 p.m. to 9 p.m. That is renewable energy integration with electric mobility. As you all know very well, the electric vehicle is going to play a major role, vital role in our Indian roads and also in the international roads. The charging station is an important parameter, important point. For a single charge, how much kilometer can be run by the electrical vehicle has to be taken into account. Also, we have to be consider the what are all the renewable energies or the natural energies we can utilize for this electrical vehicle has to be considered and taken to be in the account. For that purpose only, this topic, session 6, is having the vital role, the renewable energy integration with electric mobility. We are already converting the conventional IC engines into electric vehicle. May this electrical vehicle should run either in the hybrid way with the city run with the battery so that the pollutions will be less, and the normal IC engines run with the out of the city so that let the pollution will have in the atmosphere, because in the out of the city we will have a lot of trees and a lot of uh, gas exchange process is there. There is a possibility of the fresh air to dilute the uh, exhaust from the IC engines is possible. So people will think, the researchers will think in the hybrid mode, in where and which type of operation has to be considered is look into account. In the same manner, while we are operating in a hybrid mode, why can't the electrical vehicle can be operated with the renewable energy source also, so that see energy neither be created nor destroyed, we know very well. How long this fossil fuel will supply all our requirements? For the simple reason, all the IC engines are used in the chemical energy is converted into mechanical energy. Basically, the chemical energy is derived from the fuel. Fuel will have basically the hydrocarbon, that is, hydrogen and carbon atoms are there. We know very well hydrogen is complete burning in nature, but the carbon will have the so-called after completion also, burning also, carbon will exist. Once again, very good evening to all of you. Today, session 5 is going to be handled by Dr. C.G. Saravanan, Professor and Director, Department of Mechanical Engineering, Annamalai University, Annamalai Nagar, Chidambaram. We welcome you, Professor, for session 5 for expert lecture. Dr. C.G. Saravanan, Professor. Professor, am I audible? Professor, am I audible? Professor, am I audible?
Hello.
Sir, CG, sir, am I audible?
Audible, Saravanan.
Yes, sir. Yes, sir. Okay, sir. Sir, very good evening, sir. Very good evening, Professor.
Very good evening. Right now, you are the principal of the college.
What, sir?
You are principal of the college, Meenakshi Sundaram.
Yes, sir. Yes, sir. Yes, sir.
Okay.
Okay, sir. Once again, welcome all the participants and our expert, Dr. C.G. Saravanan, Professor and Director, Department of Mechanical Engineering, Annamalai University, Annamalai Nagar, Chidambaram. Professor has completed his BTech degree in 1988 in mechanical engineering in Madras University, and PG ME from thermal power of Annamalai University in 1992, and PhD from Anna University in the field of IC engines and alternative fuels. So far, Professor is holding 33 years of teaching and research and administrative experience in various levels. The achievements of our today's speaker is total number of publications more than 150, H index 22 and I-10 index 51. Total number of conferences he has conducted and attended is more than 50. Total number of research papers completed so far is more than 10. Total grant received from the various funding agencies like DST, DRDO, UGC and NLC is more than 4 crores. MOE with NLC India Limited, Neyveli. Formulation of academic program for diploma in mining worth 8 crores through that MOU. Total number of programs organized, FDP, conferences, seminar, symposia and workshops more than 30. So far, Professor has guided 25 awarded PhDs and some huge number of online PhDs also there. His membership in professional bodies is SAI and Combustion Institute, USA. Without taking much of the time, on behalf of the participant, on behalf of AICT ATAL 6 days online FDP program, we welcome you, Professor, to give the design of electrical vehicles insight. Welcome, Professor.
Saravanan, thank you very much for nice introduction. Is
Thank you,
audible?
Professor. Audible, Professor. Please go ahead, Professor.
Professor Saravanan, I know is a past 30 years closely associated with me. Those days I am conducting a FDP program. He is a participant. Right now he is a coordinator. He is organizing program. I congratulate his team members. The topic of faculty development program, energy electrical vehicles in India, opportunities, challenges and futures. Today present scenario about automobile sector, particularly in the electrical vehicle is dominating in replacing of IC engines are there. Our students are much worried because most of our students are did PhD in IC engines. It is a big question mark for the near future. But don't worry, some of the heavy vehicles, heavy duty engines, other marine applications, still IC engines are live. But some of the light segment, medium segment vehicles are converted into electrical vehicles are there. The topic chosen by the coordinator is excellent present scenario will be there. So today I am covering different segments of electrical design of the vehicle. Number one important component is called as a battery. Number two is called as a motor. Number three is called as a charging system. I am going to explain briefly what are the design concept of that battery, what are the design concept of that motors and the charging systems are there. What are the challenges are there? What are the opportunities available in India will be there. So if you look at the slide, what are the basic working principles of electrical vehicle, controllers and battery chargers, braking system and DC converter and challenges for the future. So, electrical vehicle is 20th century electricity was preferred in automobile propulsion. In advanced internal combustion engine, especially greater range of gasoline car, refueling, growing infrastructure, mass production of gasoline vehicles. Gasoline cars are equivalent electrical vehicles and decline the electric populations. So main objective of going for electrical vehicle is, number one is called as a pollution level. Aware of that automobile pollutions are carbon monoxide, hydrocarbon, NOx emission, particulate emission, regulated, unregulated emissions are particularly major metros are there. So what is a solution or what is alternative for that IC engine? Only best option is going for electrical vehicles are there. So what are the advantages going for electrical vehicles? You are having a zero emission vehicle. The another name of electrical vehicle is zero emission. There is no noise at all. For running cost less than 1 rupees will be there. So these are the greater advantage going for electrical vehicles are there. But other side, if you are going for battery, how to replace that existing battery? That is presently what is the toughest situation for going for electrical vehicles. So what are the types of electrical vehicles are there? Battery electrical vehicles are there. All electrical vehicles and they're battery powered and electrical driven. That is number one. Number two, hybrid electrical vehicles. In the hybrid electrical vehicles, there are two power sources are there. One is called as IC engine sources, another one is called as battery sources. both the things are available. It is called as a hybrid electrical vehicles, and plug-in hybrid electrical vehicles are there. It is nothing but the one time operation is done by the battery, another time run by the IC engine concept will be there. It is a dual operation. That is called as a plug-in electrical vehicle and fuel cell electrical technology. Present scenario, most of the R&D labs are focusing in the fuel cell electrical vehicles are there, just replacing the battery. The battery concept is replaced by the fuel cells are there. So these are the 4 variants are available in the electrical vehicles are there. In the present scenario, that battery electrical vehicle only for light segment will be 100% success will be there, for particularly in the 2-wheelers and the light segment vehicles are there, and mass scales are number of electrical vehicle concepts are there. But one drawback available after COVID, the lithium batteries are imported from China. After COVID, what will happen will be that completely Indian government stop all import from the China. That is the biggest challenge for the battery concept of lithium. So that is why it is a bottleneck is in this battery concept will be there. That's why most of the automobile industries, particularly Tata Motors, Ashok Leyland, and Mahindra are going for a hybrid electrical vehicles are there. And lastly, some of the R&D labs are still focusing on fuel electrical vehicles. If you're going for Sikri, Karikudi, number of fuel cell divisions are there. In IIT Madras, some of the IITs are doing a fuel cell, separate divisions are there, separate centers are there. Concept is focusing and replacing the battery using the fuel cell concept. That hydrogen fuel cell will be there, and lithium fuel cells are there. Number of fuel cell concept are introducing will be there. And the hydrogen fuel cell is one of the easiest and the best mode of the fuel cell technology for the electrical vehicles are there. So what are the challenges facing in this electrical vehicle? Number 1, scarcity of raw material and battery manufacturing. Already I explained. Important, the source of the electrical vehicle is called as a battery will be there. Just the entire IC engine is replaced by one small battery will be there. So the battery is consist of a number of anode and cathode will be there, number of cells are there, which is producing the electrical energy, sir. It produces electrical energy. It is a main hot source of the entire vehicle is called as a electrical vehicles. So this is one challenging is called as a raw material. Still, lithium materials are highly available, abundantly available only for China, and number 2, South Africa will be there. But in India, so few areas are abnormally is available lithium material, particularly Himalayas areas and Rajasthan areas. The lithium materials are available. Now government of India focusing how to remove that materials from the Himalayas areas. It contains the lithium materials. Still some of the R&Ds are going on in this Indian side will be there. So main drawback is raw materials. Still it is depending upon across the country. Number 1 challenge. Number 2 challenge, investment and production infrastructure is very high. So in the life of the battery only for still now, it is only for 3 years. Maximum 3 years will be there. After that, what is that? It is you got to replace it, but a new one. So what is the cost will be there? It is highly expensive will be there. So present scenario, the infrastructure is very tough situation for the biggest challenge. Number 2 will be there. Challenge number 3, and investment and standards. Investment is very high will be there. So Indian government now replacing that, what is the partial replacement of the starting of e-vehicles will be there. Number of subsidies will be given. Number of industries or small scale level industries are starting and manufacturing say e-2-wheelers will be there. Number of 2-wheeler segment, 50% subsidy rate will be given for the infrastructure will be there. That is a challenge number 3. Challenge number 4, environmental production and battery waste and disposal. That is that you can see the cartoon. In the cartoon, what will happen? Number of batteries are thrown outside. Where it is how to dispose, how it is recycling it. It is the biggest question mark will be there. Whereas in IC engine, what will happen is you got to dismantle it and melt it and reshape it and convert into another product will be there. That is advantage going for IC engines. But in case of battery, what will happen? It is a disposing another one of the biggest challenge for environmental issues. And finally, challenge number 5, high availability of fossil fuels. High availability of fossil fuels means it is going for high altitude. If we go for Ladakh, we cannot use in battery vehicles. So only still depending upon the IC engine concept will be there. So high availability of fossil fuel, we need not go for e-vehicle or hybrid vehicle concept will be there. So these are the challenges facing for e-vehicles are there. Next slide. So challenges, how to solve that one. So in India, average household needed 5.7 kilowatt per day electricity. So the car can be having 40 kilowatt capacity of battery consuming energy equal to 6 to 7 volts of alone will be there. You can comparatively, we can see that 5.7 kilowatt hour per day electricity will be needed. Say all the houses, for example, take one two-wheeler, one four-wheeler, two numbers, we can calculate is how much electricity will be needed. So this is one of the biggest challenge. It is having 40 kilowatt will be there. So already, say some of the states are facing electricity crisis will be there. Going for summer season, most of the household items are, most of the houses are running, the air conditioning will be there. Some of that major cities, 3 hours shutdown of electricity will be there. Why? Because of mismatching the supply and demand will be there. So the production of electricity, production of current is not up to the level will be there. So still we are depending on the renewable energy will be there. Some other states we are going for 100 kilowatt, 100 megawatt solar energies are there. Some other areas are using windmills are there. Some other areas are using the wind energy will be there. So we are going for alternative energy. So in this situation, whether using electrical vehicles, it is a biggest challenge will be the number one. So renewable energy sustainable source integrated with the stable grid, building and a renewable energy grid will be there. And the use of charging system, smart grid customers sharing the data and the ability to manufacturing will be there. Number using facilities of the program, users utility of the same balancing with this customer gap will be there. User collaboration and the education system and build an efficient vehicle will be there. The last one, almost all the buildings having charging stations are there. If you go the vehicle by office by morning 9 o'clock, far away from 200 kilometers or 150 kilometers, just a plug in within 3 hours, 4 hours while returning to deplug it and come out that electrical charging station, return back to home will be there. So we can building the efficient vehicles or charging systems are there. So these are the challenges how to solve that existing problem of the electrical vehicles. So now I can just rewind about electric vehicles. Siemens 9040 is a German federal achieving the what is called say electrical vehicle. You can see that is a very complicated design will be there. It is a very small kilometers, 2 kilometers or 4 kilometers run by the electrical vehicle will be there. And Detroit, Thomas Edison where 9071939 will be the country's National Museum American History through the Wikimedia. It is again in that electrical vehicles. So now AAN Wikimedia 1902 to 1919 will be there, and kilowatt 1961 will be there, and Wagengard Seaberg Citizen 1974 will be there. General Motors e-vehicle number 1 1996, and then the Chevrolet 2007 will be the introducing that what is electrical vehicle, sir. Texas roads are, it is a hottest what is a present scenario where Texas will be there doing a lot of R&Ds and the electrical vehicles are there. This vehicle can run up to 400 kilometers, 600 kilometers without quick charging will be there. That is a Texas is doing a lot of R&Ds, the latest technology of transferring to electrical vehicle, Texas. Now in India, Ratan Tata, only man doing indigenously. You know Tata Nano car, it is the only indigenous product will be there. Most of the automobile industries are depending upon the foreign technology. If you take Korean, Hyundai Motors Korean will be there. If you take Maruti, it's a Japanese will be there. Mahindra, French people will be there. Ashok Leyland also tie up with the some US based companies will be there. Only Ratan Tata group will be there doing indigenously. New Tata Edition, electric car, we can run about 1000 kilometers world record. The battery life is given Ratan Tata about 10 years warranty for that. What is the cost of the vehicle? It is about 1 crore rupees will be there. It is a kilometer is 1000 kilometer will be the one time it is a charging will be there. It is at high-end vehicles, highly sophisticated vehicles will be there. Most of the components are indigenously manufacturing. Some of the components are imported from across the country will be there. So electric vehicle, how it is work? It is a basic concept, just replacing the gasoline engine or diesel engine using the electrical motor. It is similar to the electrical train. In the electric train, almost all diesels are remote using one battery, one what is called as a car, that is electrical motor is a. Similarly, electrical power vehicle, motor is a heart of that vehicle and the battery is a input of the vehicle will be there. So controlling the power from array of the rechargeable batteries will be there. That is a basic concept of the electrical vehicle. So what are that now? I'm going to discuss today what type of battery can be using, because battery is a heart for electrical vehicles, number one. Number two, what is type of motor using for a electrical vehicle will be there. And then third part is I'm going to discuss about what is that, how to design of the vehicle will be there, and the electrical vehicle. So these three areas I'm going to cover. So number one hot topic is battery will be there. Now, what are the types of battery? That is called as application of the battery, working principle of the battery, design of the battery, and characteristics of the battery will be there. So currently focusing on the battery technology, advanced lead acid battery, lithium battery, flow and metal air batteries, sodium ion battery, lithium sulfur battery, super capacitors are there. Some of that industries focusing on super capacitor will be there. Earlier, we are still using as a lead acid battery will be there. The lead acid battery, we know cathode, anode will be there, electrolyte, sulfuric acid is there. You check the specific level will be there. The life is only small numbers of cycles are there. The output of the battery only 200 amps to 300 amps will be there. Highly expensive will be there. It is a very difficult to running the electrical motor. So what is the next alternative? Next alternative is called as a lithium ion battery will be there. Because the lithium having high energy density material, the atomic number is 3. So it is very, very flimsy, very lightweight material will be there. Storing of high energy, quickly charging, quickly energy releases. So one of the excellent characteristics are available lithium battery. And currently, what are the technologies focusing? The last one is called as a super capacitors are there. So super capacitor, it is almost similar to that of the battery will be there. So it is a less expensive when compared to the lithium materials. Next slide. So these are the applications. If you look at the slide, so what will happening will be the clock. Again, the battery will be the dry battery. If you go to watch, if you go to laptop, mobile, cameras, and finally these batteries are shifted to the automobiles. So light segment, heavy segments, all the applications still depending upon the battery will be there. One small battery, the country fate will be changes. Small battery, country fate will be changes. And the Rajiv Gandhi incident, only dry battery will be remotely operated. That explode the material will be there. So the application is entirely different. Okay, this application for automobile application, that application for destroying the country of the applications are there. So introduction of the battery, convert that chemical energy into electrical energy, and relationship between the chemical take place and the electrochemicals are there, and what are the electrolytes, and what is that composition of electrolyte in electrodes or anodes or and cathodes are there, what are the materials are there, how the electrons are moving from cathode to anode, or the luminosity, how it is take place. It is a simple concept. Simple concept of the battery will be the, all of you aware of that, how it is the battery is working. Next. So what are the electrodes? What is called as a positive terminal? Second one is called as a chemical reduction and gaining the electrons or the cathode. It is called as a positive. And anode is called as a negative. It is called as a oxidation, chemically take place. Lose the electrons. The lose the electron is called as anode, and gaining the electron, we are receiving the end is called as a cathode. That is a gaining the electrons are there. In between these electrodes are completely immersed in this what is called electrolyte will be there. If it is a liquid battery, if it is a solid battery, semi-solid form of electrolyte is available. The separators are there in between cathode and anode, what is called as a separators are there. So ions are moving from electrode terminals, current flowing from battery to perform a work will be there, and the separation of ion transparent from electrical transport devices are there. So now we can look at, and lithium batteries are characteristics. Lithium is called as a 3600 ampere hour gram. The carbon is called 300 to 1000 ampere hour gram will be the 7 to 12% volume expansion, and silicon is 280% volume will be there. Lithium and titanate is zero strain component. So these are the composition of anode. So already I told you one anode is called as a removing of electron. And these are the combination, and it is made up of a anode material. And if you look at the other side, it is called as a cathode. LiCO O2 will be there, LiM2 will be there, LiMnO2 will be there, lithium ferri will be there, lithium manganese will be there, lithium cobalt will be there, 120 to 180 amps per gram will be there, and volume of expansion 1 to 3%, and what is a voltage depends upon 4.2 to 2.0 volt depending upon these material. So the lithium batteries important thing is anode and the cathode is are there. So the played vital role, and the lithium, what are the anodes, what are the cathode material will be there. So these two materials will be the important ingredient in generating the current will be there. In generating the voltage variation from 3 volt will be there. If you look at that lead acid battery, all the cells only 2 volt will be generated. It is a fixed. But in the lithium ion batteries are the voltage vary from 3 to 3.5 voltage will be there. So this is the greatest advantage going for a lithium material. So these are the important ingredients. What are the material? What are the composition made up of anode? What are the composition made up of a cathode will be there. Next. So what is that anode material? You can see what is the stage 4, stage 3, stage 1, stage 1 will be there. You can see what is that interceptance, stage 4 will be there, and stage 3 will be there, and what is the stage 2 will be there, and stage 1. What is that? If you look at A, B, C will be the 3 stages will be there. So if it is having flying sheet, and then flying sheet, it is a corrugator. And then the corrugator inner having small particles are there. That is a stage 3. The particles are zigzag arranged in the stage 2 will be there. The particles are arranged in the uniformly. What is called as a rows will be there. Each rows and each columns will be there. 1, 2, 3, 4, 5, 6 columns are there. 3 rows are there. So these are the arrangements in the carbons. It is made up of anode materials. And what is called as the last stage, what is that? After that, how the reaction will be take place. We can see in the CFD increasing Li content, lithium content. What is the area 4.3, area 7.6, area 5 will be the area 2.1. We can see super dense stage 1 with the stage 1, stage 2, stage 3, stage 4 will be there. And finally, what is the impregnated, all the lithium materials in the color coding will be there. So now voltage characteristics of the anode intersection, what is called y-axis cell voltage, x-axis lithium. You can see cell voltage will be uniformly almost 0.2 and 0.1. There is no much variation will be there. Almost it reaches 1. You can see LiC 32 will be there, LiC 12 will be there, LiC 6 will be there. So LiC 2 will be the maximum and the LiC 6 will be the lowest will be there. So these are the voltage characteristics versus cell voltage versus in this number of cells in the battery. So types of cells, there are 2 types of cells will be there. One is called as a primary cells, another one is called as a secondary cells. Non-rechargeable, disposable. Non-rechargeable means using the pen torch and laptop and mobile phones. These applications using for non-rechargeable. It is a disposable. The life is for 3 months or 6 months. It is depending upon the number of usage. The usage is very frequently, you can short durations will be there, you can throw it. In the chemical reaction is used, cannot be reversed. Use long period storage is required. Lower discharge rate secondary batteries. And use smoke detector, flashlight and remote controls are there. In the secondary cells, you can say rechargeable batteries. The rechargeable batteries reaction can be readily reversed. Similar to primary cell except redox reaction can be reversed and recharging electrodes are undergo opposite process or jet charging. Cathode is oxidized to produce electron. Electrons absorbed by the anode. If you look at that figure, the cathode is there, anode is there, and electrolytes are there. In between cathode anodes are called separators are. This is called as a positive plate. That plate is called as a negative plate. The separator to avoid the short circuiting, cathode and anodes are there. In the separator is made up of porous material to allow the electrolyte from cathode to anode, anode to cathode will be there. So it is highly porous. And positive plate is an electron moving from positive plate to negative plates. And while charging, it is passing to electrical current will be there. So nickel cadmium battery will be there. Anode cadmium hydroxide. CdOH2 will be there. We can see the positive terminal in that time. It is called as a button. Am I right? And the insulating ring will be there. The nickel plates or steel case will be there. The negative tab will be there. The bottom side will be there. The positive plates are there. Generally, the dry batteries are there. What is called as a negative and positive plates are in case of odd numbers are there. If you go through lead acid battery, if you go for a two-wheeler, 9 plates are there. It is a odd number. 11 plates are there, 21 plates are there, 31 plates are there. Always should be in the odd numbers. So while starting the vehicle, what is the ampere level will be needed 300 amps to 400 amps. So you got to on the vehicle in the driver first time, it discharges 300 amps. Second time, it is a 250. Fourth time, 100 time. 100. So fifth time, what will happen? All the passengers get on and push the bus will be there. So the battery is totally inactive will be there. So that is a problem of the lead acid battery. These overcome all the problems if you are going for a lithium batteries are there, nickel cadmium batteries are there. Lead acid battery, these are the very fundamental things. One group of positive plate, group of negative plates. One cell is called as a 2 volt will be there. It is having 12 volt, maximum is 12 volt. The ampere hour may be 300 amps, 400 amps. It is only a 21 plates. It is using for a light segment vehicles for the lead acid factory. The electrolyte is called as a H2SO4 and water. You want to check the specific gravity level 1.2. It is a fully charged battery. Less than 1, it is half charged battery. Less than 9, it is a fully dead. The battery is completely dead, totally inactive will be there. There are 2 terminals, positive terminals and negative terminals are there. So now look at our hot topic is what is called as a lithium ion batteries, the graphene, lithium manganese dioxide, electrolyte, mixture of lithium salt will be there. If you look at the slide, the blue color anode will be there. The anode, what is called as a one group of spectrum will be there, lithium, Li, same ions are there. Electrolyte will be there. The what is the electrolyte? Mixture of lithium salt will be there. So it is passing through that what is called as a separator. The brown color indicating the separator. The ions are moving from positive to negative will be there. The electrons are passing. It is generating electricity, and the light lamp will be luminosity will be there. Lithium batteries save the world. How it is? It is better handling the renewable energy, wind energy, solar energy, ocean energy. To favor the development of electrical vehicles, our goal to develop indigenous lithium-ion battery, market demolish Samsung, Panasonic, LG battery, and safe commentaries are there. So because of that, our Modi government, it is a developing as a Make in India scheme. Indigenous is developing. Most of the components are Make in India scheme. So battery components are developed by our indigenously. The Tata R&D Motors, Tata R&D groups are doing the battery technology will be there. Number 1. Number 2, if you go look at the South Korea, what is the pie chart, what is the raw material 17%, and Japan having 15%, and other China having 14%, and the US having 2%. There is no Indian company making the lithium battery. That is important thing. Now we are doing a lot of R&D work. The Tatas, some of the IITs, some of the R&D labs are there. In Sikri Karakudi doing a lot of R&D things are there. So what are the percentage in this Panasonic 24%, Samsung 23%, LG 16%, and others are the 8% are there. So what happening will be then the capacity of the lithium battery, presently indigenous technologies, it is percentage will be 1000 ampere hour per kg will be there. It is going out to 3750 lithium materials are there. Lithium element and battery cathodes are there. So market lithium ion batteries India projected to double-digit growth, 35% CAGR during 2025 will be there. 35%, 25. After 25, reaching about 75% will be there. In near future, we are also competing skills and knowledge through R&Ds. We develop indigenously lithium ion batteries are there. So what is that advantage? If you look at that property stable. Generally, I am an IC engine man. Just to look at the properties, what is the calorific value, what is heat and number, what is the flash point, what is that viscosity. See, similarly, in batteries, what is that voltage, what is the energy density, what is the charging rate, what is the rate of charge, rate of discharge, and temperature range, environmental, and the life cycle. So these are the important characteristics. You can look at lithium ion battery, nominal voltage is 3.6. If you go for lead acid battery, only 2 voltage. Other batteries, nickel and cadmium, nickel, magnesium only to 1.2. So maximum voltage will be generated only lithium ion battery. Number 1 row. Number 2, energy densities. In the energy densities, watt per liter is 330. It is 120 and 250. Only 50 to 60 will be the lead acid battery. So it is having 3-digit characteristics of high energy density of the material is called as a 330. What is the charging CC? Constant current, constant voltage. Constant current only nickel. Nickel, magnesium, constant current. Lead acid, constant current, constant voltage. So it is possible for going constant current, also constant voltage. It is a flexible charging system will be there. What is that rate of discharge? 844 C by 2 will be there. And temperature range, it is important characteristics. Minus 32 plus 55 degrees will be there. Others also minus 10 to plus 55 degrees are there. Minus 10 to 55 degrees are there. Environmental, it is a safe. Cadmium is a hazardous material. Lead also pollution will be there, lead acid basic will be there. Self-discharge won't be less than 3%. It is at 20%, 15%, 10%. The life cycle is what is called 1500 will be there. Others are in the negative component also. So what are the important characteristics? If you look at, this is the energy density 330 and the voltage is 3.6 and the characteristics of mode is charging, constant current and constant voltage. So these are that graphene structures are there. How anodes are made up of, how the cathodes are made up of. These graphene structures are there. You can see the microscope structures, how that the electrons are moving from lithium to silicon will be there. And specific capacity of the batteries are LTO, magnesium and graphene, and the three characteristics are there. You can see graphene is having will be there, and lithium will be there, and blue silicon will be there. So it's a megawatt of specific capacity and voltage will be the y-axis. So cathode material, similarly, what is the characteristics in the cathode will be there? What is the LCO A1, LCO B1, LCO C1 will be there. Other characteristics will be there. LCO 1, 2, 3, 4 will be there. So various distribution you can see. In this case of lithium will be there. It is the energy capacity. It go up to 200. It is x-axis. Specific capacity will be there. And the potential also, what is the voltage will be there. Up to go to 4.5 volt will be there. Now we can see, look at that specific energy density. Energy density I already told you in the earlier tabulation 300 to 350. What is in small size? Very small size. What is the material? It is a very lightweight material because the atomic number is 3. In the periodic table you check very small number 3. So it is always naturally it is a lightweight material. Very small place we can accommodate it in the lithium material. So that's why it is a lightweight and a smaller size corresponding. Volume of energy density will be the 350. And similarly, what is the power output? Not only energy density, what is the energy? Quickly energy will be released, quickly energy will be absorbed. So it is called as high energy material. It is a lithium ion will be there. Lithium ion will be the maximum will be the 300 watts per kilogram will be there. And longer run time. That is important characteristics. If you go for longer run time will be there. It is a short duration. What will happen? The lead acid battery within 50. If you look at the graph, less than 50 will be entire process will be discharged. Nickel cadmium less than 50, 50 to 100. Lithium manganese, lithium ion we can look at, it is 150. That is a duration will be, it is a double and triple the time will be there. It is a long run batteries will be there. Now we can look at lithium ion. What are the method involved in and the design of the cell and how it is a fabrication. That is called as a step 1 electrode sheet preparation. Already told you there are two types of electrodes, anode and cathode will be there. That is called as a, you can see that anode is called as a brown color and the cathode is called as a blue color. In between that, then the violet color is called as a separator will be there. That is called as a anode, cathode, and one cell is consist of one anode and one cathode. In between one separator will be there. That is called one cell. What is the voltage will be there? 3.5 voltage will be there. Energy density 300 will be there. Lifetime also 150 will be there. So these are the peculiar characteristics. High energy material is called as a lithium. So now, if you look at how to preparation of the sheet metal, it is called sintering process. Number 1. You know what is sintering? It is one of the die will be there. Makers of the die, it is preparing in the sintering. You can look at that right side of that machine, it is called as a coating. And then sintering, it is called milling and preparing the slurry and finally coating. So the coating is important thing. What is a thin film coating will be there. What is called as a micron size coating will be there. Very, very thin film will be there. So if you coated more than 1 micron, 2 micron, the active or the site will be reduced. The active site is reduced. The generator of electrons from cathode to anode, anode to cathode will be reduced. So it is called as a thin film coating technology will be there. This is called as a coating machine. This is called as a rolling and pressing machines will be there. How that converters are doing. How it is doing the anode and cathode. This is called as a preparation of slurry material. You can look at that vessel is a slurry kind of, it is a carbon, graphene. The graphene materials will be there. How that solidification and then it is a sheet metal is coming out of the rollers. These are the right side diagram. If you look at, these are that anode materials are coming out, the sheet form will be there. Very thin sheet form. Both the sides are coated with this graphene materials will be there. This is the preparation of a anode. And the cell assemblies are there. What is the cell assemblies? After sintering, going for ultrasonic welding. There is a welding technologies are there. Very small thin films are there going for ultrasonic welding to weld that cathode and anode in between one separators are, and finally what is called as a winding process. If you go look at, this is called as a winding process machine, and this is called as ultrasonic welding machines are there in this diagram. Everything automation will be there. It is not manually done. It is not manually done will be there. It is a case sealing, and finally outer casing will be there. Any battery outer casings are there. The outer casings are what is called spot welding and grooving and positive welding, electrolyte filling and crimping will be there. Grooving machine will be there, clipping machines are there. All that the machines are available in Sikri Karakudi will be there. Sikri Karakudi, this is a manufacturing divisions of lithium ion batteries are there. What are the process involving? Completely in the welding process, what is called spot welding, welding for grooving and electrolyte filling and clipping, and finally made in a what is called casing will be. So why even use them? Lithium ion battery, incredibly efficient. The stuff amount of energy thinly packaged that keep phone, laptop running all the days. 365 into 24 hours, we can running the phone, running the laptop because of the lithium battery will be there. Lithium battery cells are very manufactured technology. Unlike a manual tech, they can get more volatile as time goes on. It is important to underline it is a volatile material as time goes on. So this is how they, because demand higher capacity batteries, more slim package and cheaper prices are available. This may also production flaws, design flaws, problem in impurity, industrial pressure and market competition. Outer back and become explosives. The cathode anode touch each other, in short circuit will be there, it is explosion will be the fire. And manufacturing process error every rate. This is not a case every time. Most of the time phones or other devices are exploded because error in the charging process. The error in the charging process, some of the subsequent slide I will show you how that and the vehicles are exploded, how that vehicles are catch a fire will be there, how cell phones are exploded while charging because of the error in the charging process. Next one, overheating, also avoiding the overheating, dropping the device effectively through battery behavior will be there. Next, don't reverse the positive negative terminal. Do not short circuit batteries. Do not short circuit batteries. Recharge dry or lithium primary batteries. Do not use different types. Question. More important, these are that non-certified fake nest cost. Next.
Previous program, sir.
Please. Photos of me. Yes, next.
Explosion, sir.
No. Next. Now you can look at how that luxury cars are towards catching the fire in near February 18, 2022 because of the batteries, some malfunctionings of the batteries, entire vessel will be fire event will be there. And then next.
Explosion.
This is also some of the Tesla vehicle caught fire while plugged off at a supercharger station. What is called as a supercharger station? Very quickly charging will be take place. What is the Tesla vehicle will completely caught fire will be there. Next, this is a practical living in Telangana State Road Transport Vehicle. While charging, what will happen? Catch the fire will be there. You can see the video of how the fire will be took place. Next, previous slide. Now, charging one. And now look at the last part of the battery is called as a charging. Current, constant current charging, called voltage constant, current voltage, both current and voltage will be the pulse charging, trickle charging will be there. Say the first two charging is very easiest to process, and third one is the lithium ion battery using for current and voltage will be there, and quick charging will be there. That is called as a supercharging. Now, if you look at what is the charging methodology, constant current up to what is called 1 amp will be there. It is a down charging current will be decreased. It becomes 0 will be there. Now it is a charge capacity will be there. It is a constantly increasing. It is what is the charging capacity is 100. Charge float voltage it is fixed about to 4. The cell voltage will be the charging rate will be the charging rate. It is up to 2.5%. It is 100%. Cell voltage it is a maximum up to 4 voltage. Maximum lithium battery 3 to 3.5% will be there. So this is the characteristics of what is the charging of the batteries. Lead acid battery recently next. So what is the charging? You can look at energy weight 30 to 40 watt-hour per kg, 60 to 75 watt-hour per liter, power weight 180 will be there, watt-hour 4 hours. Nickel zinc 60 to 70, energy volume 170, power weight 900, 2 to 3 hours watt-hour. Lithium ion battery, you can see it is energy density is 160, it is 270, 1800, it is 3 hours will be the maximum, minimum and the maximum 5 hours will be there. Lithium polymer battery, it is excellent characteristics, is 130 to 200 energy volume is 300, 2800 for power weight will be there. Again, it is charging whatever will be there, 3 to 5 will be there. So these are the charges. If you look at all the plugging will be there, the plug will be 3 pins are there. Instead of fuel tank, you are having charging plugs are there. It is 3 hours maximum. This vehicle will be completely charged, 100% charges are there. Battery charges. It is another different companies are Delta, Magneto, Pickup, PEC, 120 volt will be there. And charging is done by power grid. Good charger monitor the battery voltage, current flow, battery temperature, minimize the charging time. Yes. So charging stations. What is the level 1? 240 volt. India, Japan, and the 3.5 kilowatt. And the type of the vehicle 4 watt, 3 watt, 2 watt. That is a type 1. And the level 2 DC, it is China will be there 15 kilowatt. 15 kilowatt will be there. Level 2, it is China 22 kilowatt will be there. And level 3 and European Union and India is 4.3 kilowatt. And level 3 DC and Japan and the European Union 400 watt will be there. We can go up to power 400 watt. These are the type of the companies are available. So these are the charging 2 parts. Charging system with the trunk of car. It is nothing but a ATM card. Just inserting the card, the charging plate will be there. Just quickly it will be charging will be take place. It is a wall mounting chargers will be there. So what is equalizing? These important characteristics for the charging. So almost all the cells are charging here. There is no need for in this cell. There is no need for charging. In this cell, what will happen? Almost full. The yellow color will be vacant. Similarly, it is yellow color is vacant. It is overcharging will be there. So overcharging also affecting the entire cell. That's why you go for equalizing. Any cell what is a vacant available, it is insufficient available, empty available. Accordingly, that particular cell will be charges. That is why it is called as a equalizer will be provided. The circuit battery of the system overcharging. Cell voltage too large, more than 4.3 short circuit and discharge into back terminals. Continuous cell discharge current, it leads to what is a 2.3 centigrade. Cell voltage, it is very 2. Some of the speciality of the circuit provided for balancing. Some of the positive TC will be there, temperature is too high will be there. But if you look at that, the diagram, and the capacity of that graphene, it go up to 4 volt maximum. It is a capacity, it go up to at least 100 will be there. So these are the characteristics discharge of the profile. From 4 volt to what is the capacity, what is the about 100% capacity will be. What is the handling? How it is explosions will be there, injuring person and damage to the property will be there. It is high energy density, low self discharge, lithium ion batteries offer greater advantage compared to conventional rechargeable batteries. That is one of the greatest advantage why we go for lithium batteries are there. So these are the some comments getting back from the media. Mobile phone exploded during the charging. The family of Maharashtra injured with the severe burns are there. Because what is the reason for that? It is overcharging. Number 1. Number 2, what is happened? Temperature reaches abnormal in the beyond the controlled temperature. Number 2. Number 3, what will happen? Each cell already charged. Again, you will recharging the cell, what will happen? Rechanging the threshold limit to explosion will be take place. Please go. Now, mobile phone explode, man pagan Mumbai restaurant take the hospital. This is at social media. What is that? Mobile phones, you know, lithium battery. Again, it is overheating will be there. What happening will be there? Completely exploded. Next. So Samsung massive Galaxy Note recall the bring battery will be there. It is a dark data, bright future will be there. The Samsung fellows, what will happen? Return back all the batteries are there. So those are the batteries are something explosion will be there. Some batteries are not charging. Some batteries are malfunctioning. The Galaxy Note will be there. Return back to that Samsung. Next. So that is a Telsa vehicle already in the caught fire while plugging the supercharger. This is an important thing terminology. The supercharger, what will happen will be there within 5 minutes time. Maximum 5 minutes will be there. We reaches the all the cell will be 3 volt will be there. It reaches about energy density 3 watt. That is at the supercharging stations are there. Now this already seen some caught fires are there in the Tata. Now any queries related to battery. Now you can discuss. In the first phase is over. Next phase is going for motor. Any queries from the audience side? Just 5 minutes, you can interact with me. Audience. Hello, is audible?
Audible, sir. It is audible, Professor.
Yes, any queries from the phase 1 of the battery section?
Yes, sir. Yes, sir. 1 second, Professor. Participants, is there any queries in this part 1 of this session 5? Please clarify with the expert speaker. Participants.
Yes, Saravanan. The participants are live, the live mode or unconnected mode?
Live, sir. They are in live only, sir.
They are live means at least some need interaction. I spend more than 1 hour about
sir. Sir, there is a question, Professor. Disposal of battery affect the environment? That is the question. Is disposal of battery will affect
disposal of battery is called lithium. Lithium, what is there available? Cathode, anode, and separators are there. He cannot refixing the cells are there. Entire battery can be thrown out. How it is a recycling? That is one of the biggest question mark. One of the biggest challenge for recycling of the batteries.
Another, sir. No queries, sir. No, continue, sir, please. How to avoid? Dr. M. Karthikeyan has asked a query. How to avoid the environmental degradation because of the battery disposal?
Sir, battery disposal still we are not having the technology for recycling of batteries. Recycling technologies are not available. How to dispose it? Again, dispose into open node will be there. Okay, that is a problem will be there.
Yes, sir.
In near future, some of the technologies are available. Recycling of all the batteries are there. So I will tell you one example. I went to Japan 10 years back. What will happen? Instead of petrol bunk or battery bunks are there. Just batteries, cars are going about 400 kilometers. Just check the net and go to that battery bank. They're replacing all the batteries and allotting new battery will be there. So that is a technology available 10 years back. So need not worry about the charging and other things. So affordable price after reaching the 400 kilometers, that what is the new battery will be inserted in the battery rack and the old battery will be replaced by new one. It is what is called compatibility will be there. It is uniformity will be there. All heavy vehicles are there. This is the technology available 10 years back will be there.
Yes, Professor, another query is there. Sir, electric vehicle, how much kilometer may possible to drive?
Sir, at present, what is called hybrid vehicle, Hyundai Motors, it maximum 250 kilometers for 3 hours charging. From my place to Chennai, 250 kilometers. The battery will be completely dry. Again, you go for charging 3 hours and return back from Chennai to Chidambaram. So it is maximum as a date only 250. But most of the data is telling 400, 450 and 500. But it is not a genuine one. It is we conductor some drive, test drive. We go up to 250 kilometers, 4 passengers. So average speed of 60 to 70 kilometers. Average speed of 70 kilometers, 4 passenger, non-stop from here to Chennai, 240 kilometers. The battery almost what will happen? Completely dead. So again, the recharging of 3 hours, again come back from Chennai to here. But running cost only less than 1 rupees. One of the advantage. Number one. Number two, there is no noise. There is no noise pollution at all. Number three will be the environmental zero emission vehicle. These are 3 advantages going for a electric vehicle.
Thank you, Professor. Another question is, again, Dr. M. Karthikeyan has asked, EV vehicle used to charge, it needed electricity. Electricity produced by fossil fuel. It affects environment.
Yes, definitely. And the first say I already told you, because the challenge is what is called as a energy. All the houses will be there 4 kilowatt. You are using 4 wheelers, four electrical vehicles. What will come to exceed that? There is no electricity at all. So better the charging is done by renewable energy. So one of my students is conducted experiment through air, through wind. The charging of battery will be there. Still in R&D is going on our lab. So the tiny project is given about 25 lakhs. Through wind, we got the charge of battery. So it is a renewable method, so charging without affecting the fossil fuels.
So that fossil fuel depletion can be avoided or minimized.
Minimized.
Yes. Professor, another question. Mr. Santosh Kumar has asked, considering the life cycle assessment, battery management might potentially increase pollution, surpassing that of the fossil fuel combustion. How can we effectively manage this issue?
Sir, the battery management still is under the R&D level only. Is not completely fulfilled the what is a requirement will be there. A number of issues are there going for battery management system. Okay, so we want to replace some of the things will be there. Otherwise, what will happen? Again, we can run only 2 wheelers. Some of the light sector vehicle. We are not going for a heavy duty vehicle. So other vehicles are there. Still, it is R&D will be there, battery management system.
Yes, Professor. Another question from Muttumari has asked. 1 second, sir. Sir, electric vehicle, how much? You have answered, sir. You have answered. That's all. That's all, Professor. No queries, sir. All queries you have clarified, Professor.
Okay, we'll move to another section.
Yes, Professor. Yes, Professor.
By motor, hybrid power. Now we look at what is our earlier slide. We show the electrical vehicles. Now we are going for a hybrid vehicles are there. Hybrid means there are 2 powertrains are there. One is IC engines, another one is a battery will be there. Now you can see hybrid, ICNQ, plug-in hybrid, electrical vehicles are there. Nexo will be there, Texan will be there, Kona will be there. So these are the all Euro 6 and the temperature emission controls are there. It is one of the on-road vehicles. Kona is available currently. They are launching by Hyundai Motors are there, and next on Tata Motors are launching the one vehicles are there. Again, it is approximately 200 kilometers are there. So what are the advantage going for hybrid vehicle? Within the city, we can run by battery. So what is the advantage? What is the advantage will be there? In Chennai, number of signals are there. Each signal what will happen 60 seconds. From Tamaran to Paris Canal, how many signals? More than half a dozen signals are there. If you park the vehicle, it is consuming the fossil fuels and emitting the carbon monoxide, hydrocarbon, NOx. Will be there. We across the city going for what is the mode? It is called as IC engines mode. So this is a concept of the hybrid vehicle. In Maruti Sias introducing a light segment of a hybrid vehicles are there, and Tata Motors, most of the vehicles are now in the hybrid concept are there. Completely eradicating all the 2 wheelers, particularly peak traffic time, passing vehicles converted to what is called as a electrical vehicle, and 4 wheelers converted to hybrid mode will be there. So in the hybrid, there are 2 power sources. One is battery, another one is called as a IC engine concept. Now you can see hybrid, different 3 types of hybrid vehicles are supported by that electric different degrees will be there. 48-volt hybrid vehicle, it is called as a battery assistance. It is called as a dual power hybrid. It is a plug-in hybrid vehicles are there. The plug-in hybrid is a combination of battery and IC engine. The charging is done by the chargers, the battery. And hybrid concept is in the IC engine return back the energy to charge the battery will be there. So these are the various segments, primary power segments. It is called as the combustion engine with the electrical support. The petrol engine, electrical motor working with the unbalanced performance, and the electrical motor is concept of the flexible recharging the options. Now, Exxon 48 hybrid vehicles. Normal combustion engine powered by car, how we can run the electrical deceleration, conservation of fuels. It is an enhancement of traditional starting, and the fast and smooth engine starter with the city will be there. So 1.6 GD engine is a gasoline direct injection, 1.6 GD engine, 1.6 CRD engine, 1.6 CRD engine, and 2% CRD engine. It is a 48 volt electrical system acceleration supply at 12 kilowatt. They reduce the fuel consumption, CO2 emission. What is a battery? You are using lithium ion polymer battery, 0.44 kilowatt hour. Regenerative braking system. What is called as a regenerative braking system? The subsequent slide I am going to explain how with the effect of braking will be charging the battery. Now you can see hybrid. What is that hybrid concept? Hyundai Motors and CO2 emission 102 gram per kilometer. The fuel consumption 62.8 will be there. Electrical motor will be there. Lithium ion battery will be there. This is a gasoline direct injection system that is called as a maximum compact of the lithium ion battery. It is a hybrid concept of the entire scenario will be presented. Now you can look at plug-in hybrid vehicle. Plug-in hybrid vehicle, IC engines are there and the electrical motors are there, and it is a completely charging is done by from IC engine to battery will be there. That slide will be explained what is called as a regenerative braking system. You know what is called regenerative? While moving in the inclined surface, high kinetic energy will be there. With the help of high kinetic energy, and they return back the energy to the battery will be there. So that is called as a regenerative of the charging of the battery. That is called regenerative braking systems are there. If you look at charging of high voltage battery power in electrical motors, what will happen? You can charging high voltage. You have the high voltage. It is low speed electrical motor. Very low speed. It is done by the what is called as a battery. Low speed. Number two, while upskill, what will happen? The battery is not sufficient. It is a power is given by the IC engines. The petrol engine combination maximum power will be given because it is inclined surface. It is need more thrust, more power will be needed. If you inquire for hybrid concept will be there. Now mid segment, constant speed will be there. Constant speed what will come? Sometimes you are giving the battery, it is sufficient for running the vehicle. If you are going a deceleration, deceleration means completely stopping the IC engine. We are get back all the kinetic energy to the battery will be there. So this is called as a regenerative braking system. So it is called hybrid energy flow. There are 4 different configurations. One is called low speed and starting, acceleration on the inclined surface, acceleration constant speed in the plane surface, in deceleration with the inclined towards in the ground. The kinetic energy will be generated and the charging of the battery. So these are the hybrid energy flow systems are there. Now Kona, already I told you it is a maximum torque is 40 and 1000 kilometer per hour, 9.7 seconds will be there. What is called 0 to 100, 9.7 seconds will be there. In the drive the vehicle up to 250 kilometers will be there. The maximum 3 hours charging. Charging fully charging, what is called as a 6 hours it is a fully charged. It reaches 250 kilometers. What is advantage? Zero emission vehicles are there. At least 4 persons are sitting. It will completely connected by AC will be there. Completely thermal management system will be there. If there is no noise, there is no vibration. What is the electrical motor using 140 kilowatt electrical motor? This is called lithium. The blue color shield is called lithium ion polymer pack. This is a battery will be there. This is India's first electrical SUV vehicle from introduced by what is called Hyundai Motors. If you look at that video of hybrid mode,
Seven times. 7 times. In 4 నిమిషం ఉంది సార్ 4 minutes ఉంది సార్ వీడియో ప్రెస్
Previously. Previously. So in the audience, we can ask some questions related with the hybrid electrical vehicles. Now you can see that 4 minutes of the videos of Hyundai Motors. That is that Sonata hybrid concept. Within the city, it is completely operated by the battery. But city limit is crosses over. The hybrid mode is converted to IC engines modes are there. During the city mode, some energy will be spent by the battery. That energy will be get back by the IC engine source will be there. So that is called as a regenerative braking system and fuel emission and emission controlling mechanism. And what is the most effective thing is noise. There is no noise pollution at all. So these are the things done by the Hyundai Motors and the Kona Electric. Tata Motors also doing Textron. Number of hybrid vehicles are now in the launching in cities are there. It is 8 lakhs rupees will be there. That is a name board is called as a number board is called as a green color mode. It is that indicating is called as a battery operator vehicles are there. Now you can throw some questions related to the hybrid mode. Saravanan. Any questions from audience side? Saravanan?
Sir.
Saravanan, any questions from hybrid
Yes,
vehicle?
sir. Neeral has asked how to prevent over temperature of battery while charging on fast DC charger.
It is having controlling technologies are there. Now latestly introducing sensors. The flow current will be controlled and cell temperature also monitor, cell voltage also monitor. Immediately what is the inflow of the current will be there.
Okay, sir. Thank you. From Muttumari, one more question. Sir, how long the battery will works? She's asking about the battery life.
It is battery life. How long you can running the vehicle will be there. Max life of the battery is 5 years. Lithium battery will be there. It is a cost about the 6,000 to 7,000 rupees will be there. You can imagine that every once in 5 years you got to spend about 6,000 rupees exclusively for battery.
Santosh Kumar, another question is asked. Considering the life cycle assessment, battery management might potentially increase the pollution, surpassing the fossil fuel combustion. How can we effectively manage this issue?
That is why disposing of the battery is the biggest challenge for the battery management system. Okay, that's why we go for some other materials, cheap material, lightweight materials. But there is on board with the lithium, there is no equivalent to lithium. So only source is lithium, number one. Number two, it's recycling is important. We just remove the material from cathode, remove the material from anode, again redepositing, re-coating the material, reusing the material will be there. So it is one of the source for recycling of the battery. Hello.
Sir, no questions, sir, from audience side.
We go to phase 3. It is a motor.
Yes, sir. Yes, sir.
The last part within 5 minutes. I will just complete. Go
Yes,
for
sir.
motor.
Yes, sir.
Now that is motor. Next. Next. Previously. Now what are the important electrical drives will be there? Continuous duty drives, short time duty drives, intermittent duty drives. What are the controls? Manual, semi, and automatic will be there. And the types of motor, that is the important thing. In the last row, it is called as a DC drive and AC drive will be there. So this is most of the vehicles are DC drive is there. Some of the vehicles are AC drive will be there, and converter will be there, and controlling method will be there. And finally, how it is effectively introduces in the electrical vehicles. What are the advantages going for DC? What are the drawbacks going for DC? What are the advantages AC? What are the drawbacks will be there? And different types of motors are what are using currently using electrical applications. Next, no, next, previous slide. Motors. The car can be using AC and DC. DC motor average running roughly between 96 volt and come from forklift industry. DC installation simplifier. Another DC motor can be overdrive short period up to 10. Be good for short burst for acceleration. One limitation, heat buildup may lead to the self-destruction. That is the motor. Yes. And now if you look at these are the DC motors are using, these are the AC motors are using in the electrical vehicles are there. The concept of the motor you know very well. Stator will be there, rotor will be there, brush will be there, commutator will be there. It is similar to that basic working principle of the DC motor, basic working principle of the AC motor will be there. The AC motor quickly charging will be there. The DC motor it will take some time will be there. So most of the vehicle using the ACs, concept of the alternating current motors. Yes. Now Tesla, what are the motor are using? Now we go to that electrical vehicle and the real condition Tesla. 3-phase 4-pole AC motor is using. 3-phase 4-pole AC motor. What is that? Torque will be there, 273 will be there, maximum 5400 RPM. What is the HP will be there? 21.5 kilowatt will be there, 6000. Maximum torque 350 Newton meter. Maximum speed 13,500 will be there. If you look at the graph, you can see will be there. Electrical motors. Motor speed will be there, the torque will be decreases. The motor speed will be increases, the torque will be decreases will be there. This is for a again another Tesla motor of a photographic view. Now, if you look at what is that energy efficiency of the motor, it is a maximum what is called a Tesla. Tesla it is called 1.14. Almost other things very the Honda City, Honda ICE, and Honda and Toyota. This is Tesla will be the maximum what is called as a ampere hour efficiency 1.14. If you look at the performance characteristics and efficiency versus and acceleration will be there. The efficiency will be decreases and acceleration will be increases. This is a characteristics curve. Almost these small triangles are matching with the characteristic curve. Within the curve limit, we are attaining the maximum what is called as a 60 miles per hour acceleration. 60 miles will be there. Here maximum efficiency what is happening at 2.6 we are getting the efficiency. Now what is the controlling mechanism will be there. The driver press accelerator pedal. The potentiometer is varying. We can controlling the DC controller. This is a voltage. This is a volt maximum. It's come down again reaching come down. It's a 1000 pulse per second will be there. 48 volt will be there. The control drives controlling the volt or voltage depending upon the potential output, controlling the speed. This is a DC control characteristics. What is the voltage? What is the temperature will be there? This is we can see what will happening will be there. This is the rectangle width will be increases. The rectangle width and the time duration will be increases in the voltage. This rectangle again further, it is on position to off position will be there. Now the AC controller. Now you can see earlier slide is a DC controller. It is a AC controller. What is a battery? 12 volt battery, charger, controller, AC motor, transmission. What is a battery volt? 300 volt will be there. Now these are some of the characteristics of the 3-phase AC motors. Next. And now we come to the design side. What is my presentation is design of electrical vehicle. So far we have to discuss only battery and motor. What are the important parameters and design? Now what is the total mass of the vehicle? Number 1. What is the rolling resistance? Number 3. Aerodynamic drag will be there. What is the front area? And the transmission is efficiency. So these are the important parameters. Number 1. Acceleration time will be there. Within the seconds, 10 plus or minus 1 seconds. Maximum gradability, low speed will be there. Maximum speed, it is a 160 km per hour. This is a condition. Design specification, motor size, design of gear ratio, verification of acceleration performance, verification of gradability. Design of gear ratio, we can see motor speed. What is a motor speed? What is a motor characteristic? We can look at the motor torque. We can key out the maximum 1000. After that, what is done? It becomes the flat. There is no variation. What will happen in the torque? The torque will be gradually decreases. So it is optimum will be the 1000 to 1500. Now we can, what is the vehicle speed? What is the distance? What is the acceleration? It is a 10, and what is the vehicle speed is 100 km. So we fix it, these two criteria. Next, design of the engine. The design of the engine, what is the vehicle speed? What is that? The resistance will be the wind resistance. According to the aerodynamic resistance, hill climbing resistance, the characteristics curves are there. These curve, it is called as a gradability, and what is it with respect to vehicle speed will be there. Now what? You can see energy capacity is, it is called as a different driving cycles are there. Each cycle is called as a starting point is end point. It is a one cycle. This is one cycle. This is one cycle. In this cycle, having acceleration, deceleration, stopping, and starting, off, everything will be there. It is called as a cycle. It is called as a cycle to cycle variation. Cycle to cycle variation of the power. Cycle to cycle variation of motor power. You can see the motor power, what will happen? Almost constant. There is no variation. If you look at vehicle power, increasing, again come decreasing, increasing and decreasing. This is order. This is engine power output. It is a power output of PPS. It is a energy change in PPS will be there with respect to time. The fuel consumption, what is the speed, what is the motor output, what is the power output, everything will be explained in the fuel consumption. This is important characteristics while designing the vehicle fuel consumption. Yes. So this is about the design of the vehicle will be there. With this knowledge, I will share some of my views regarding the design. The design will mean a number of things will be there. I am outlining about some of the design parameters of the electrical vehicles. That's all about my presentation. Any queries will be there. I might hand over the email to the coordinator Saravanan. He will circulating you through mail. You can contact me.
Participants, is there any queries from the expert? How does the charging power impact the battery life? Deepa Patel has asked the question, how does charging power impact battery life?
Say, already I told you, one cell is 3.5 volt. If it is exceed 3.0 volt, what will happen? The battery cell will be completely damaged. That's why we provide an equalizer. Equalizer means the battery cell completely charged. Need not go for that particular cell. The cell will be completely stop charging, going for another cell. That's why we ought to prevent the battery for overheating, to also safeguard the battery will be there.
Yes, Professor. Yes. Professor, lot of participants had expressed their thanks to you. Very nice presentation. Thank you, sir. Very informative session. Thank you, sir. Wonderful session. Informative lecture. Thank you very much, sir. Like that, lot of participants, they expressed their thanks to you, Professor.
Once again, I thank the Saravanan. He's giving me an opportunity to, after a long time, I make a PowerPoint presentation. After more than 1 year, again come to the new dimension of hybrid vehicle. Currently, we are handling the subject hybrid vehicle. So what does that IC engine people is slightly moving towards that hybrid concept. That is a future trend of the R&D, particularly fuel cell technology. The fuel cell technology is a hot topic. So number of R&D groups are working in SICRI and PAG, Anna University, IIT doing fuel cell. So fuel cell is a hot topic doing the IC engine supporting of future alternate fuels of the automobile. Once again, I thank the organizer and patiently hearing my lecture. With any help, any queries, I give the mail to Professor Saravanan coordinator. Through mail, you can contact me. Thank you very much.
And now we move on to the Thanksgiving session. We thank Professor Dr. C.G. Saravanan, sir, Professor and Director of Mining Department of Annamalai University, Chidambaram. Sir, thank you very much. In spite of your busy schedule and personal commitment, you have accepted our invitation, and very nice and lucid presentation you have given to this ATAL FDP program, sir. Thank you very much, Professor. I know officially and personally you are the authority in the field of IC engines. Participants, if you have a chance to visit Annamalai University IC engine laboratories, Professor has created from small nano size to mega size, all IC engine, and later, as Professor rightly told, move on to the hybrid vehicle and battery related things with a lot of funding, lot of his own personal interest, and lab is open 7 days, all 365 days. If you have any chance to visit and meet Professor Dr. C.G. Saravanan sir, and you can get an insight and idea for your PhD and as well as further post PhD related items. Even I got personally motivated because of Dr. CGS sir, and a lot of, as he rightly pointed out, lot of his FDPs as himself as coordinator, national level, international level, conducted at Annamalai University. I have attended and got benefited. That's why Professor being an authority in the field of this area, I requested him in spite of his personal and official schedule. Professor has honored that. Thank you very much, Professor.
Thank you once again.
Prabhu sir, are you in online, sir?
Yes, sir, I'm available.
Okay. Next, we move on to the third day, session 6 of this 6 days ATAL FDP online program. Session 6 deals with the topic of renewable energy integration with electric mobility. Now, I am happy to introduce the expert speaker of this session 6. Dr. T. Prabhu, Managing Director, Energy Solutions Ltd, Coimbatore, Tamil Nadu, India. Dr. Prabhu Thangavelu is the Managing Director of Piyok Information Private Limited, Coimbatore. It's a pioneering cloud-based ERP provider and software product company dedicated to driving business growth. With a profound understanding of unique challenges in the manufacturing sector, Dr. Prabhu has positioned as a trusted partner of manufacturers seeking the streamline operations and achieve scalable success. As a passionate entrepreneur, Dr. Prabhu being the extensive experience spanning research, academia, and industry. He has worked with multinational corporations, leading significant research projects across automotive, defense, and industrial product domains. Leveraging a system engineering approach, Dr. Prabhu has successfully delivered large-scale projects collaborating with cross-functional and multicultural teams across multiple countries. As an environmental enthusiast, Dr. Prabhu has worked on energy conservation, thermal system design, and product optimization, reflecting his commitment to sustainable innovation. He is an active member of Indian Society of Systems for Science and Engineering and involved with the fluid mechanics and fluid power communities. Under Dr. Prabhu's visionary leadership, Vyog is committed to empowering business with cutting-edge ERP solutions that drive efficiency, enhance sales growth, and ensure customer satisfaction. Without any further delay, on behalf of AICT ATAL Online 6 days FDP. We invite session 6 expert speaker, Dr. Prabhu sir, to address the gathering. Welcome you, sir.
Thank you, sir. Thanks a lot.
Thank you, sir. Thank you, Dr. Prabhu.
Yeah. So, is my video is on, sir?
Yes, sir. Yes, you are audible and the video is on.
Fine, great. Thank you, sir. Thank you. Thanks for the nice introduction. And good evening to all the participants. And it is a great opportunity to present in this forum. And I am very much thankful to Dr. S.V. Saravanan, sir. And he is on guru of me in Maharaja. Long back, it is around 25 years back, and he is the thermal teacher for us, and he taught us a lot many things. And with his inspiration, I have taken that energy as a specialization in my PG. After that, I continued my research in computational fluid dynamics and work for automotive as well as product company. I work for multiple multinational companies, and then I back to PhD for 10 years. And currently, I am owning a company which is involved in ERP as well as we are into energy solutions. So this is my background, and really, I'm very much thankful to Saranan sir for inviting me to this August forum, and I'm happy to take this session with all of you. I'll start my presentation. So the topic given to me is renewable energy and EV charging integration. Basically, all of you are familiar that probably last 3 days you are hearing a lot many lectures about that electric vehicle, and this is about the charging point of view. And when it comes to the charging, if we are why we are going for EVs to reduce the carbon footprint, but when we go for the charging with grid power, then again we are changing the gear from one place to another place. So probably it may be good for Delhi like kind of cities where the pollution is more. With the EV, they can reduce the pollution in the concentrated cities, but still they burn the same amount of carbon. So that's why EV charging should not be with the grid power. It should be with an renewable energy. So that is the topic of interest today, and I'll walk through some of the interesting things. And can we move on to the next slide? Yep. So probably you're all familiar with the renewable energy systems. So wind, solar, and other renewable sources are the promising energy sources for producing the power. Why wind is prominent? So if you see that one wind power is now it is matured, and almost all the subsidies for the wind power is taken out. And if you see that in India, almost all the energy wind concentrated locations are all covered with wind turbines, and so many research is going on the wind power generation. We are going for that large power generation, so 1 megawatt, 2 megawatt, like that. Scaling is going on because they want to tap the potential wind energy available sources, as that also now become a rare commodity. So many of the turbines are re-engineered and they are replacing with the new type of turbines. So that is the research going on the wind power. And when it comes to the EV charging, we may not be relying on the big wind turbines or large type of wind turbines. So that's why the research is towards the small wind turbines or the Pico wind turbines. I'm not sure how many of you are heard about that one. It is about that wind power available. Normally, that urban areas, the wind velocity is around 3 to 5 meter per second, which is not sufficient for the large turbines. Whereas if we come up with the technology which can produce the power for the low wind speed, that is going to be the game changer in the market. So that is the kind of research is going on for the wind power. And can we move on next? So solar is, I think, previous slide is there, and you are all familiar with the solar energy, and it is exhaustively available in a country like India. And nowadays, solar is also maturing, and almost it becomes cheaper to install and get the power. And when it comes to the EV charging, now it's like chargers are happening like petrol pumps. As the range is coming with 400, 500, still then we need to have a frequent charging points. That's why if you see that one, many of the Indian oil pumps, they are coming up with the EV charging points. Also, some of the resting areas in the highways like hotels and any other bay areas are they are providing with the charging stations, but they are mostly powered with grid power. So the idea here is why can't we use the solar and wind together as an source of energy for the charging stations? So that's about that integration of energy systems. Also the energy storage systems. If you see that one, the vehicle is powered with the battery. The battery need to be continuously charged and it should have the capability to store the energy for that range. So the thing is, energy need to be stored, integrated, and it should be available for the vehicle for the long range. So that is about the need for the R. Next slide. So this is one of the vehicle to grid. It is a different kind of thought process, as all the vehicles are powered with the battery, and sometimes the battery is charged and may not be utilized. So when the vehicle is connected with the grid or the charging stations, if there is a shortage of power on the grid, it can extract the energy from the vehicle. So this is a different type of thought process, but the life of the battery depends on the number of charging cycles. So again, the research is going on in this segment also. Vehicle to grid technology. Next slide. So this is about the hybrid renewable energy systems. So if we see that one, as I already discussed, if all these renewable source of energy are climate dependent and it is not consistent like a grid power, like thermal power plants, you can switch on and switch off like that. It is not possible. Whenever the energy is available, we have to tap it. Sun is available in the day and wind is seasonal, and other sources also it is not continuously available. So we need to hybrid the energy systems as well as storing the energy systems. So all these things should in sync with the EV charging. Next. So again, it comes to the incentives, because IC engine cost and electric vehicle cost, when we compare it, it's going to be a little bit costlier. So the government is providing a lot many incentives for promoting the infrastructure and also the EV vehicle. There are a lot many policies and procedures are there, and the government is continuously revising it and giving incentives for vehicle as well as wind power, also solar installations. And now they are trying to decentralize the power generation as much as possible. That's why that rooftop solar is becoming a popular, and government is giving enough subsidy for installing it, so that almost we will be a net zero kind of thing. So like all the power we can generate, use it, so that we need not depend on the grid connectivity. So this is about the government support for enhancing the renewable infrastructure. Next slide. And this is the another important thing, corporate sustainability initiatives. I hope all of you are familiar with that ESG goals. Each and every company has to submit their carbon footprint, and they need to year on year they should submit that how much they are consuming energy, how much they are emitting carbon, and every year they need to reduce the carbon footprint, so that they will get some tax benefits, or sometimes there will be a penalties for them if they are exhaustively using the energy. So probably I'll take few minutes in this slide and take a little outside the context of this presentation. And if you see that one, European Union, if you want to do a business with the European countries, and they are insisting that ESG goals. As we are near to, I'm located in Coimbatore, and nearby Tirupur is an big export market segment, and they export the garments and textile things. So they are getting the heat from the European Union, and they are telling that what is your energy goal and how much are you emitting, and what is the path for the reduction of that carbon. So in this initiative now, Tirupur Export Association is taking a lot of initiatives towards the energy conservation as well as reducing the carbon. So last year we conducted a conference on decarbonizing India, global conference on decarbonizing India. So in that, so many initiatives proposed by the corporates, basically waste to energy, like all the used water bottles are converted into textile, synthetic yarn kind of thing, and they are using that for making the t-shirts and stuff like that. And kind of dyeing process, they are introducing green dyes, and they're reducing the chemical footprint. And similarly, other industries like cement and all, they are into the reducing the carbon, and they are into energy conservation point of view. If you see that one, making the cement is a highly energy intensive industry, like steel, cement, and like glass industries are all very high intensive in energy for making the product. So they are also taking an initiative towards that decarbonizing. And if you see that cement industry, they are reducing the coal consumption by utilizing the municipal waste, because that they put it into the incinerator. Whatever it's a classic example again in Coimbatore, that ACC plant is in Coimbatore. They collect the garbages in their municipal area, like that Madhukurai it is located. They collect most of the garbage from the community, and they segregate it, and the organic waste goes to the vermi composite, and then inorganic and plastic kind of thing goes into the cement plant. So they calculate the calorific value and segregate it, and then put it into the incinerator to gain the calories. So that is one kind of initiative, and a lot of heat is exhausted because a huge amount of burnt gas is coming out, the flue gas is coming out from the industry. So that they are recovering, and a few initiatives we did to recover the heat and produce the power using an CO2 cycle. So why I'm telling at this point is corporates are forced, as well as they are taking the initiatives to reduce the carbon footprint. So in this context, many of the automotive industries and so many other industries, they are encouraging their transportation with an electric vehicles, like within the campus, as well as they give some incentives for their employees if they use the electric vehicle. So this is a kind of carbon reduction, and this is again connected with the ESG goals. So they have to calculate that how much energy they are utilizing it. There are different levels, internal and process wise and allied things. So it's a kind of life cycle analysis they'll carry out, so that they can calculate that emission, how much they are emitting, and what are the initiatives they are taking it, so how they are reducing it. The point here is because of the environmental as well as the community initiatives, corporates also involved along with the government to reduce the carbon footprint. And the good thing here is so many research is happening around that each and every segment, And because of this forced or need, so many innovations are happening, and we are getting good technologies along with the what to say, that AI and computer programs are all helping to optimize and enhance the system. So takeaway here is, so as much as possible, all the corporates are forced to do it, as well as they are willing to do that, reducing the carbon footprint. So the point what we are discussing here is, when we are going for the electric vehicle, yes, we are using the electric vehicle without polluting, but the batteries need to be charged. How are we charging? If we are going with the grid, again we are taking the carbon. Instead, if you go with the renewable based energy, so we can aim for the zero carbon. So that is the point I just want to add it here. So we will move on. So any questions in between, maybe we can take it, or at the end we can take it. Sir, Saravanan sir, how we can take it, sir? So we will move on next. Yeah. Can we move on to the next slide? Fine. So this is about the future trends in renewable energy and charging technology. Maybe I can I'll go through one by one, but something I'll discuss and something I can skip it as you can read it. Fine. So ultra fast charging power by renewables, as we are familiar, all are facing this one. Like if you put that Tata Nano for full charging, it may take 5 to 7 hours for charging it. So that means every day for driving 300 kilometers, we need to put the charger overnight charging. But if we are on a transit, if you're traveling from Chennai to Coimbatore, or Bangalore to Chennai, or wherever it may be, if the total travel distance exceeds the range, then we need to recharge it. So if we are taking 3 hours, 4 hours for charging, then we may be losing the timing in the travel. And again, we need to have enough charging points in between. So to avoid that one, like when we go for the conventional IC engines, we'll fuel it in a full tank by 5 minutes or 3 minutes, we can fuel the tank. So something like that, the ultra fast charging is a need of the hour. So that so much of research is going on in that ultra fast charging. Basically, it is a capacitor design, and problem here is, when you are going for the ultra fast charging, the heat is there. So if the temperature rises, then the battery may burst and fire. So safety, so much of research is around that ultra fast charging is going on. And decentralized renewable microgrids, as I mentioned, the small pico type of turbines, and with the solar panel, with the hybrid, and decentralize the renewable microgrids. Maybe it is a community based or local based, something like that. Lot many research is going on. In the highway, they can mount a number of solar panels, and then they can connect it to a microgrid, so that every 3 kilometer or 5 kilometer you'll get a charging points through that one, along with the solar, wind. In addition to that one, so many other other power producing technologies like piezoelectric, many things are coming up. So probably those are all connected in a microgrid, so that every 3 kilometers or 5 kilometers we will get a charging point using the renewables. And AA and IoT smart charging. So as you know that charging and discharging need to be properly managed. So now these tools and instruments are helping the charging. AI is helping in a lot many ways, and IoT, that instrumentation, will help them. So much of activities are going on there. And mobile renewable charging units. So on the go, we want to charge it. Hydrogen powered EV charging. Again, this is a like fuel cell or any other technologies from the hydrogen power. If you see that hydrogen is a promising power source, maybe I can take a few minutes about the hydrogen. So we have that gray hydrogen, brown hydrogen, blue hydrogen, like that, green hydrogen. So many things are there. So probably that again, if you go for that hydrogen production, if you are taking it from the water, if you are able to electrolyze and get the hydrogen separate, then it becomes a green. Whereas normally that hydrogen is produced from the fossil like methane, ethane. So there again, the carbon is there. Whenever we are extracting the hydrogen, we are emitting the carbon like a electrical vehicle charging using the grid. So similar thing. So hydrogen, so much of activities are going on, and storing the hydrogen is difficult, and carrying is difficult. And the research is around that one, how to produce the hydrogen, how to store the hydrogen, how to carry the hydrogen in the automotive. That is the research. Research is needed for safety point of view. And if you see that one, most of the countries like US, they have developed 7 hub points for producing the hydrogen in different ways. They are located in different locations or different states of the United States. And their focus is how to produce the hydrogen and how to store it. Each and every hub is working on various concepts. And one more concept is using the hydrogen for aviation. And so they are using that ammonia, because storing the hydrogen in the aircraft is difficult. So they produce the hydrogen from the ammonia. They store the ammonia and produce the hydrogen on the go. So those kind of research is going on in the hydrogen. So again, on the ground, it may be better than the aircraft. So this is about the hydrogen. Not many activities are going on. And energy sharing platforms, this is a concept, and how are we going to share it between the access to demand areas. So microgrid to grid, microgrid, different microgrids are connected together. As I already told about that vehicle to grid, something like that. So many innovative things are happening, probably with the help of AI and IoT. This is possible. Wherever that excess energy is there, we can tap from there and then use it for the demanding area. This need to be properly monitored and properly diverted. And urban integration of renewable power chargers, as I mentioned, that rooftop solar and wind kind of thing, and trying to use it in a safer way to produce the power. And it fine. So maybe these are all the trends in that renewable energy and charging technologies. We'll move on. Next slide, please. Fine. So this is about the research areas in renewable energy. In solar technologies, what is happening? It's more about solar panel. And again, if you see the life cycle analysis, the solar panels are made up of glasses. And after its life, how are we going to dispose it is a big question. But we'll not worry much about that 50 years or 60 years from now. But most of the things are now we are producing the power using solar panels. And now instead of going with the conventional way of producing the solar panel, now people are working on that green type of materials where it can be easily disposed, so that we can get a sustainable and reliable power source from the solar. Research are going on and it is promising, but probably the efficiency point of view need to be increased, and economics also need to be worked out, so that the technologies will come up. Probably that something like coating of paint, like a coatings can be put it over the building, so that it can produce the power. And some screen kind of thing, rollable or carryable kind of screens which can produce the power. So something like that, many things are happening around that one. And coming to the wind, so that wind turbine is highly matured in technology, and the big turbines are aiming for larger and larger power. When it goes for the large turbines, you may be familiar that allied problems like vibration and carrying that huge turbine and balancing, so many things are there, and then their drive systems, and then power, what to say, uh, uh, kind of so many things are there when we are going for the larger turbines. As you know that swept volume increases, the power production rate will increase. So everybody is aiming for that larger and larger turbines, so 10 meter, 5 meter, like that. The turbines are the blade diameter is increasing. So when it goes bigger and bigger, challenges like making, manufacturing, transporting, mounting, and then maintaining, and also the turbines are in remote location, managing the turbines. So these are all the certain things on the big turbines. But people have developed the technology to do those things, and they were able to manage that big turbines. But the new concept or the thing towards is decentralizing it. Decentralizing means we can make like a solar panel 1 kilowatt, 5 kilowatt, something like that. We can go for the small scale turbines. So one of the interesting thing we worked earlier is like in all the mobile uh, towers, they are located in a lot of areas. Before this 5G era, the earlier towers are, you maybe are familiar, large towers will be there with maybe 20-meter height, something like that. Large towers will be there. We did some research on that one, because they are away from the grid location. Mostly they are powered with the diesel power, and 24/7 they'll run. So instead, why can't we provide, as it is in a higher height, we can provide with the small turbines which can produce a 10 kilowatt, or which is needed for that powering the tower. We did a good survey on it, and so some of the vertical type turbines are promising in that one. And some development happened, and we tested in that wind tunnel, and we studied that. Mainly the thing is we need to improve the characteristics of the blade, so that the stalling will not happen, so that the power will continuously increase. And another thing is at the small wind speed also, it need to start and run. It's a very interesting thing when we worked on the small scale wind turbines. And nowadays different concepts are coming up, and then maybe oscillating type, rotating type, various other concepts are coming up on the small scale wind turbines. And it is not too far. We can see like solar panels, we can see the small wind turbines which can be hybrid, so that whenever the wind is available, it produces. Whenever the sun is available, sun will produce. So both the things can be stored and utilized whenever it is needed. So that is about that hybrid energy systems. And as we are going with the AI powered, it can manage that demand and supply, and accordingly that will help the user. And so another thing is about that optimization. And so whatever that available, we have to optimize it. Basically finding the location, installing it, right type of technology, and continuous monitoring and troubleshooting. And these are all the certain things we need to do it. And nowadays these are all possible. If you see that one, wind is highly unpredictable earlier, and always that Tamil Nadu Wind Power Association will go for that. Their produced power is not properly tapped or wheeled because of the excess power available in the grid. So nowadays, the wind power prediction models are helping in a bigger way. And how much is the power produced in the next 5 days or 10 days, they can predict it, and accordingly they can increase or reduce the thermal power so that maximize the wind power utilization. These are all the advancements in the technology, and because of the continuous effort of researchers, academicians, and industry, community is getting benefited. So just a flavor of that research, how it is progressing, I just try to cover up in this slide. So can we move on to the next? So this is about the energy storage and management. So battery is the current storage mechanism, which is easy to carry, and energy density is high in the batteries. And in battery also, there are different materials they are using it, so that they are also trying to go towards the green battery technologies. And when it comes to the storage, thermal energy storage is there, and then compressed air storage. There are so many type of storages are available, but again, it's a efficiency or performance point of view. How are we going to store it? Only thing is, battery is giving the better efficiency when we are storing and discharging it, and the life is also good for the battery storage systems. And if you see that one, lot of research is going on in the material side and element side, and the type of that batteries. And in batteries also, the thermal management is an big area. If you see that most of the EV vehicles, they are having a thermal management is a huge problem for them, as we saw about the ultra fast charging, and similarly when the discharging is happening, so the energy is lost in terms of heat. So if we are not able to properly vent the heat, then again there is a problem, and reducing the heat is important, and heat generation is important. In addition to that one, venting the heat is also important. So all these things are managed nowadays with the proper measurement systems, as well as control mechanisms, with the help of automated programming and AI-based, AI-driven mechanisms. So we are able to control and deliver the better results in this storage area. So move on. Fine. So this is about the grid integration and smart charging. Basically, that as I already discussed about the vehicle to grid technologies, this seems to be odd, but still it is worth to explore the technology. Whenever the vehicles are connected in the charging point, if the grid is deficient, it may get that power from the battery itself. For example, if the vehicle is kept charging for 7 hours or 8 hours for the overnight charging, so sometimes if the grid is not having enough power, so they can draw the power from the battery. But it is not advisable in terms of battery life point of view. But still, that it's worth of trying the technology research in this area. And decentralized renewable microgrids, as I already discussed about that one. Now that the concept is decentralizing, like if you see that one, cold rooms, I'm just taking an other example. Cold rooms normally they keep it near the market, like they bring all the perishable products and store it in the near the market. Like if you see all the chain stores, they have a cold room, so they bring the fruits, vegetables, and they keep it in the storage area, including milk and other stuff. But the government now, it is pushing that during the transit, it will lose its shelf life on the transport. So instead, if you are having a cold rooms on the harvesting point itself, then it is the shelf life of the perishable products can further enhanced, and you can get the quality of the product. So if you see that one, decentralized cold rooms are coming up. Basically, cold room is nothing but an refrigerator. So it's a kind of a small room kind of thing with the proper insulation. They'll have the refrigeration unit, and they have different rack or arrangements to keep the products at different temperatures. Only thing is the driving for the compressor or the refrigerant unit requires the grid power. Some of the remote places where the harvest is happening, they may not have the grid power. So there, the government gives some incentives for producing the power and installing the cold rooms over there. So something like that. So here also the decentralized renewable microgrids helps them to produce the power. As I already told that along the highway, if you are having the multiple solar panels and small wind turbines, they can produce the power in the highway itself, and every 3 kilometer or 5 kilometer, if you are having a small microgrids which are connected along with the highway wind and solar panels, so that the vehicles which are passing through that one, they can get a power at a frequent intervals. So the microgrids will help, and also that multiple microgrids can be connected so that they can complement each other, who is having more power and who is having deficient power, where the demand is more, where the demand is less. They can be managed using the microgrids. And IoT based enabled smart chargers. So again, this IoT is nothing but an instrument cluster where they are connected with the software, and they can understand the need and requirement, and accordingly they can manage it. So when there is a power deficit, they'll identify and automatically charge that one, and when there is an excess power, they can cut off it, and they can use it for the multiple purposes. Blockchain for energy trading in microgrids. Again, when there is a excess of energy, we cannot lose it. We can get benefit out of it through this blockchain technology. You can sell it, and then whenever there is a need for us, we can get it, like a smart metering. Whenever there is an excess power, it will be supplied to the grid. Whenever there is a deficit of power, it will draw from the grid. And if the grids are all connected with the renewable, it's completely green. So the blockchain technology will help that transactions, and so that we can make money out of it in the process. Fine. Next. Fine. Maybe if you want to have any clarifications, maybe I can stop and we can discuss it, and then we can take it. Otherwise, it should be a monotonously I'm keep on talking.
Participants, is there any queries? Please
I
raise
am
it.
getting some questions.
Yeah, shall I
So-
read it?
Yes, sir. Please, sir.
What should be the ideal generator for wind charging for small scale, and what should be its rating, same as wind turbine or higher? Shall I repeat it, Prabhu?
Yes, sir. I'm getting that question, sir. It depends on the turbine, whatever that powering we are doing it. So normally the small wind turbines, we can 5 kilowatt or 10 kilowatt, whatever may be the power generation is there. The problem here is that cut in and cut out speeds. So at the small speed, it has to start running, and similarly at the high speed, it should cut off. So probably it is a trade-off there between which type of generator we have to select. Probably that BLDC type of things are promising in this segment. So this is really a critical one. We even that turbine we can develop it, but the power generation using the generator is a big thing. So whichever is suitable for that particular condition, we need to select it. Again, electrical side, yeah, a lot many things need to be carried out for the small wind turbines. Your question is right.
Deep Patel, are you in online? Deep Patel?
Yes, sir. I am online, sir.
Yeah, see, don't type the question in the chat box. Please talk to the expert.
So
Okay,
I'm
sir.
happy to hear from you.
Okay,
So
okay.
is it,
Because
am I answering you?
ITTC,
Yes, sir. I almost, sir, got it, sir.
Yeah, good.
But sir, main concern is for the domestic or the small scale, the cutting speed or what should be the rated wind speed as per the condition is
Yeah, in urban condition, we continuously monitored in Coimbatore. So the thing is, normally we'll get 3 to 5 meter per second, which is not sufficient for the cutting speed. But we have to develop a blade profile which can start producing it. May not be a high power, but at least it should start generating the power in a fraction of watts also. That is the aim in that research. It depends on the availability, right?
yes, sir.
Yep. So normally that 3 to 5 meter is available in most of the urban areas. And again, city to city, it varies. So this is about the Coimbatore I'm talking about. So we have a wind monitoring system, continuously it monitors, and we predicted or find out the seasonal variations during the June to probably up to September, we have a high winds. But when it comes to the city, and it will have some channelizing effect because it located in the Palakkad Pass. Some of the areas will get high wind, some other areas it will be less wind, and they have some high-rise buildings would have some channelizing effort. So within the campus also we studied it, a lengthy high-rise building, and that underpass we have one opening. So there we'll get a high wind. So something like that we need to locally study that wind, and then that's what the importance is. Selection of the site and availability of the wind is a good first thing we have to study it.
Okay, sir. Thank you, sir.
Welcome.
Deep Patel, from where you are talking, your affiliation?
Patel, you are from which place? Sir is asking.
Oh, okay, sir. I didn't get that. So sorry, sir. But I am, sir, from Gujarat, Ganpat University, Mehsana.
Great. Good. So you're into any of these research?
No, sir, but I am pretty much interested in wind
Very good.
technology. When we
Very good.
generally talk about the wind power technology,
Yep.
then the main concern about is its tip speed ratio and power coefficient. So, sir, I
Yes.
thought about when we talking about the charging through the wind power, then same consideration need to be considered for this also.
Yes. It's all turbines. Again, if which type of turbine we are talking. So when we are going for the turbo machinery type, like rotating machineries, then the tip speed and all comes into picture. Some of that oscillating type and various other technologies are coming up. Like a tree itself, there will be some oscillation, that is a reciprocating motion. So those will also generate the power, but these are all fractional. When we talk about that pico turbines, they'll produce a small amount of power. But the thing is, multiple turbines connected together will give a considerable amount of power. Like if you see that small uh, fan inside the computers, which is used for CPU cooling. So like that array of small blades like that is capable of producing 5 watt or 10 watts. So if you connect 100 or 200 fans like that, they'll also generate a considerable amount of power. It's a kind of harnessing. How are we going to harness the power from the available wind?
Yes, exactly.
Yes, sir. Yes, I got it, sir.
Fine. So mostly it's about that swept volume, how much volume we are having it and what is the wind speed. So based on that one, we'll get the available power And again, the beds limit will restrict the maximum tapping efficiency of the power. Fine. Anything else? Any more? So I'm stopping. It means otherwise it will be monotonous and you may not get the interest. That's why I'm stopping at this point to take few questions. Basically, I'm into. I worked on small wind turbines and using CFD as well as wind tunnel, so that we studied multiple parameters of the wind blade, aerofoil blades, and how they are helping on the power production. So, and also the biomimicking type. If you see that one whale, if you see the aircraft's wings, you might have seen that at the end they have a flap. Earlier it was not there. So those are all the things which will talk about the fluid mechanics, reducing the vortex and increasing the efficiency. So kind of biomimicking it. It's from the whale how they are swimming in the water, and similarly birds how they are flying, something like that. So one of the thing is bionics is an interesting topic. Nature has abundant technology. If you are able to observe that one, we will able to get so much of technology from the nature. For example, like if you see that hummingbird, it will flutter and it can go front and back, and without any vibration it will consume the nectar. So these are all the examples of how they are using it. And similarly, if you see the owl, when they are flapping, you will not get little sound itself. There are some interesting videos available in the National Geography channel when the eagle, dove, and this owl, when they are flying, how they are making the flapping and how they are generating the sound. They studied that one. Owl is having a small winglet in it so that it will suppress all the sound, though there is no noise or sound at all when it is flying. So very interesting. We can learn so many things. So these are all the points for energy drop when it is making noise. So some amount of energy is spent for generating the noise or vibration. If you are able to reduce that one, that can be used for a useful output. So these are all some of the derivatives we can learn from the nature, and then we can adapt it. So very interesting things are available nowadays. You can Google it or browse it, or from the YouTubes you can learn lot many things. Fine. So any one or two questions, then I can move on. Fine, I'll move on, and maybe at the end I can take one or two more questions. So research areas in hydrogen and emerging technologies, as I already discussed about the hydrogen. So there are different types of green hydrogen, gray hydrogen, like that. They are naming it in different ways. So hydrogen production and storing and transporting is needs certain research and cost-effective green hydrogen production. So electrolysis is the green hydrogen concept. So when we want to produce the hydrogen, we require electricity. Again, that electricity, if you are consuming it from the grid, again we are generating the carbon, and which is not solving the purpose. So we need to go with the renewable energy sources for producing the hydrogen from the water. That is the energy required and producing the hydrogen from the water. As I already told, that ammonia, if it is naturally available, it is fine. And again, if you are making that ammonia and we are producing, means ammonia is made from the, again, fossil combinations. So that only thing is we are differing or changing the carbon location from one point to another point, but it depends on the need. Like electrolysis is not possible in the aircraft engines, so that they are taking that concept of ammonia to hydrogen, so that hydrogen powers the engine over there. So these are all the innovative ways of producing the hydrogen. And wireless renewable powered EV charging, already it is available for the mobile chargers. So probably harnessing it, and for the high power vehicles, if the technology is extended, that will be very much helpful. On the go, as I told, that microgrids, we can keep it in the highway. So along that, when it is we are driving, you can charge it. No need to stop and charge the vehicle. So that is a very convenient way of charging and driving the vehicle. And compact hydrogen refilling stations, like for fuel cells, you require hydrogen. Probably like battery exchanges, one of the concept nowadays people are using it. I think Activa is introducing that concept, and something like that. Small refueling stations, like you can canister kind of thing, we can take it and insert into the vehicle, and you can drive it continuously. So these require some ecosystem, or some of the supply chain is required. So something like that need to be identified, and you can use that one for the compact kind of refueling stations. Advanced materials for energy, as we discussed about the battery and other stuff, we require a material research, and people are working on it for the identifying the green materials, which is easily disposable, as well as having an efficient and long life. So huge research is going on in that material side. And when it comes to the recycling and kind of waste to energy, so much of activities are going on, especially that battery, when it is ends its life, it needs to be recharged, or we have to reuse it. Basically, whatever the rare materials available in that one, that should be reused, and so that we can save the nature as well as reduce the carbon footprint. I'm not sure how many of you are aware about the life cycle analysis. So the life cycle analysis, if you want to make a battery, it starts from the raw material. The raw material may be lithium, iron, whatever it may be. And the lithium, again, how that lithium is made, we have to go for the root of that one, how the iron is, they are getting it, and sodium means how they are getting it. So there may be a method of harnessing it, or extracting from the ore. So there will be a process involved in it for making the materials. So that, again, those are all consuming the energy, including that mining of that one. You require a lot of mining equipments. Transporting that ore, you require a transportation, and then processing in the industry, in the processing unit, you require huge amount of energy for converting that from the ore to raw material, and then that raw material comes into the battery making unit. So these are all the raw material life cycle, so that how much energy is spent and how much carbon is spent on that one. And then when it comes into the plant, that undergoes so much of changes in the plant, that requires energy, and for making that one, and again there will be some waste disposal. All these things should be calculated for the life cycle. So basically that life cycle analysis tells that which is the right material for that particular product, how to avoid the highly energy consuming, highly waste generating one, highly environmental impact one. So those are all the things it will identify, and suggest the researcher, or suggest the manufacturer which type of material they have to use it for, which type of process, and how to make it. Every product are having that life cycle analysis, including if you take any of your cell phone or a television, and they have a process from making it to disposing it. And if you take a cell phone, if it is having only an 1 year or 2 year of life period, then its life cycle threat will be high. If we are having a long life, 5 years or 6 years, then you will not frequently change the mobile phones. So these are all the things which we are doing it for environmental friendliness. So all these things are clubbed into this for using that rare energy resources. Next slide. Fine. So probably I touch upon the different topics around that charging, and probably as it is more about the renewable energy, I touch something about the renewable energy production, usage, and its technology and its conversion methods, and how it is happening around, and what are the current trends and the technologies happening. So some of the things I discussed with you. So maybe any questions? So this is about that. I just want to share about that charging with renewables. Fine. I want to touch upon one story in this point. Maybe it is relevant. Long back in US, there before the era of IC engines and car, usually they use chariots for transportation. As that number of users are increasing, the number of chariots increased, and it is driven by horse. So one day that municipal or that mayor had convened a meeting saying that we are keep on increasing the chariots, and number of horses are increasing. So now we are having a different type of problem, like whatever the dung it is making, the disposal is become a very difficult. So they started doing certain research on how to dispose the waste from the horse. So why I'm connecting it here is there are keep on the technologies are evolving, and definitely there is a solution for one type of problem. So now the era is like we are moving away from the IC engine, and as we are talking about IC engines are generating carbon, and carbon is emitted to the environment. Because of that one, we are getting the climate impact and greenhouse impact, temperature rise, and because of that one, glaciers. So there are nexus of things we are discussing it in connection with the automotive transportation and carbon emission. So the new technology is EV, and when we are talking about EV, and again the charging becomes a question. Are we using that grid power? If you are using the grid power, again there is a carbon emission. So how to control it? We are going for the renewable. So now the technology is towards the renewable and producing the energy from the non-renewable sources, use it for the application. And tomorrow there will be a question comes, how are we going to dispose the solar panels? And again there may be some thought, if you are consuming all the wind power, how it is going to affect the climate. So something like that keep evolving. The thing is, researchers are need to be continuously innovate and find the solutions for the problem. All the problems are having solution. So today we are having some problem with the technology, tomorrow we'll find the solution, and probably that technology become obsolete and new technology will come up. Today we are talking about EV and driver vehicle. Tomorrow there may not be driver, or even the concept of transportation may change. Probably drones may take up, or connected vehicles. So something like that. Continuously technology is evolving. We need to keep an eye on it, and then we need to think ahead. So that is the point. I just want to share it at this point in time. So any questions? I'm open to discuss related to this, or related to energy, or decarbonizing, or something related to aerodynamics, or related to this.
Participants, kindly post your queries.
So probably I'm ahead of the time, I think.
Yes, Dr. Prabhu.
Yes, sir.
20 minutes are there.
Yeah. So any questions related to this or something related to energy, I am happy to answer if I know.
Participants kindly interact with the expert.
So as I restricted with the renewables and energy for EV, I restricted the presentation with minimum content. So I did not deviate much from this content.
Sir, if you have any practical on-site reading with respect to energy or EV or anything else renewable.
Many things I can share it, sir, but the interest to the audience, I can share my experience with the cement industry, how we have used that energy conservation and wind turbine power production and small hydro plants. So many things like I can discuss.
We have
some things.
either extempore or some video or PPT.
Right now, I'm not having actually. I'm connecting in the mobile. I don't have any content with me, but I can share few case studies what we are familiar. One thing I can talk about that the cement industry, and maybe it may be interesting to all how the energy is spent and what is the threat for that cement industry and how they are coming up with the new novel technologies. Maybe I can share few minutes about that one.
Yes, sir,
yeah.
please.
Fine. So probably it may be interesting, little away from the topic, but it's more about the energy. So if you see that,
it is a case study only, nothing wrong. It's
yes,
a case study.
yes.
Please proceed, sir.
Yeah.
Please
so that cement industry, you may be familiar that it's a highly energy intensive industry, and they are consuming huge amount of heat energy for producing the cement. And if you see the infrastructure growth in the country or across the globe, everybody needs cement for the construction. And if you see that road construction, bridge construction, or whatever it may be, all are infrastructure driven, and everything needs a cement. So until there is a substitute, cement is going to live for longer, and it also consumes huge amount of energy. You may be a little familiar. I just give the brief about how the cement is made. So it's a more of calcination process. They are making the calcium and heating it to the very high temperature. Tons of calciums are put into the kiln, and the temperature they are maintaining around 1500 to 1700 degrees Celsius. They are maintaining in the kiln. To have to generate huge amount of heat for as it is high temperature, also the volume is very high. Huge amount of heat need to be generated. It's like a coal power plant kind of thing. They consume a huge amount of coal to produce the heat. So if you see that one after 1500 or 1700 degrees Celsius, the heat is recovered a certain extent for the process, but after that it is exhausted into the environment. Huge in terms of metric tons of energy is exhausted into the environment. So they have to recover the heat. What they're currently they are doing is they are preheating the coal or the ore. So both the ways they are preheating it, but still they are not that much efficient when we are when you calculate the energy efficiency point of view. So what we suggested them is, instead of going with the preheating, we can go for a power production, because huge amount of energy is available. Like we can run a thermal power plant, and the suggestion is not to go with the regular conventional steam generator and produce the power with the Rankine cycle. Instead, we come out with the new novel idea called CO2 as a working fluid. So it's a transcritical fluid. When we are using the CO2 as a working fluid, it has a lot of advantages. Similarly, there is a limitation in it. Advantage is 1 megawatt power plant, you can keep it in a 10 by 10 room size. You don't require a huge amount of coal handling system, water management system. So like that, allied systems are completely eliminated, and it runs like a small gas turbine kind of thing, or it can be a transportable kind of thing. So this is the advantage, and disadvantage is that turbine becomes a small and small for that high power. So making of the turbine it runs at very high speed and small in size. So the material and other stuff is a complex thing to make the turbine. But everything is possible nowadays because of the advanced materials and advanced manufacturing technologies. So using that, we developed a power cycle in a simulation. So we didn't go to the actual production scale, but we developed a simulation model, that is a 1D thermodynamic model, to study that one, so that we can add that multiple components in it. So multi-stage turbine, multi-stage compressor, how to bleed it, how to enhance it. So this kind of study we made it, and it was a really an interesting thing, and we submitted it to the one of the cement plant. And so they are pursuing it. Only thing is certain technologies are not available in India, something they need to procure it from other countries. So that is one of the interesting thing, where you can produce the power instead of reheating it. A partial amount of the power can be produced from the cogeneration point of view. The main purpose of the heat is to produce the clinker, but the byproduct is you can generate the power. Probably it can support up to 60 to 70% of their power requirement for all the accessories and allied systems of the cement plant, which is a great savings. The thing what we are claiming here is you can reduce the carbon footprint, because you are not using two sources, heat as well as power. So heat is used for generating the or producing the calcinic clinkers, and the same heat is used for producing the power, so that we can reduce the carbon footprint. So this is submitted to the one of the cement plant in Coimbatore. And also in addition to that one, instead of coal, you can use the solid waste available. One of the thing is the municipal waste, I already explained. Similarly, another example for that source of energy is, you may be familiar with the tanneries. It is a huge chemical processing industry, and their effluents are very much harmful. So government put stringent norms on them not to pollute the water. So they have to treat all the wastewaters which are coming out from the tanneries. So that produces the sludge. The thing is, again, when we are treating the water, only we are separating the chemicals and water. So what to do with the sludge? So that sludge is having huge amount of calorific value. That is one of the source for generating the power. Along with the coal, if you add the sludge, whichever is recovered from the treatment plant, the dried sludge can be put into the kiln, so that it will complement the energy inside the kiln. Also, as it is at high temperature, it works as like an incinerator. The harmness of the chemicals will be degraded over there. It will not pollute the air. So if you see that one, all are nexus. What we are doing is we are treating the water, so that we are getting the getting the sludge out of it, and then that sludge again has the harmness, so that is put into the incinerator, so that it burnt and it produces the gas. So that again, that gas should be properly treated. Again, it's a cycle. So the point here is we should conserve the nature, and we should not exploit the nature. The nature has its own tendency to replenish itself, unless if we are able to use the energy for the need instead of luxury or exploiting it. So the point here is probably all process are having its own positive as well as some limitations. So the limitation should be reduced by the way of properly managing the source of energy. So this is the one classic example we did it earlier. Many things are there, like small hydro turbines. We developed some of the hydro turbines for the what to say, you can produce that power in the same way. Micro or pico turbines, you can put it in the small streams, so that the farmer can get a minimum power, maybe 5 kilowatt or 10 kilowatt, which can feed them for their lighting purpose. And probably if they are having a lighting in the fields, they can reduce the insect bites, something like that. So many derivatives are there from that pico turbines. And again, microgrid concept, all the small turbines can be connected to create a microgrids, so that energy can be utilized. That is, and again, like small wind turbines, that is a small water turbines also promising one. And there is again fluid mechanic principle can be used by producing the vortex kind of thing. You can increase the performance of the turbine. Some classic examples are available in the YouTube, you can browse through it. So those are all the renewable kind of energies, how we can tap from the available energy. The problem here is harnessing the energy is the problem with the renewable source of energies. But again, by understanding the fluid mechanics in a better way with the fundamentals, we can harness the energy in a better way. Fine. So maybe I can keep talking, but audience has to. Yes, sir.
Dr. Prabhu sir, can we
Yes.
witness a 10 minutes video regarding to relevant to our topic as a case study?
Related to EV charging, sir.
EV charging, battery electric vehicle.
Yeah, fine. Probably. So the case study kind of thing, what I can share is like we will work on the microgrid concepts. As I already talked about that on the highways, if you are able to provide a small wind turbine along with the solar panels, all these produced energy can be harnessed or connected in a small microgrid, so that the microgrid can make as a charging point for that one. Again, here, if you see that one, there are different concepts are available for the small wind turbines. Like, there is a vertical turbine or horizontal axis turbines. Those can be kept on the highways. When the vehicle is passing through that one, there will be a airflow from the vehicle. So that airflow can be connected to the turbines, which are kept on that above a certain height, so that they can produce a small amount of energy only. It may not be high energy, but small amount of energy can be tapped. So that is one of the concept. And also all the traffic signal post, which are at highly at a higher elevation, probably they may be at 10 or 15 feet or 20 feet at height. So there we can keep some few vertical turbines, so that they can generate the energy from that one. That may be sufficient for the traffic signal lights, as well as that can be connected to the small grid, so that excess energy can be managed through that one. And piezoelectric, like all the pumps and speed breakers, you can put some speed breakers, so that that can be generate some amount of energy. All these things can be harnessed, so that we can make a considerable amount of energy, maybe 1 kilowatt or something like that, or 10 kilowatt. So that is sufficient for the charging points. So we need not require a separate big turbines or big solar panels. In the highway, along the side itself, we can keep some of these power producing gadgets, so that we can get the power out of it, and that can be used for the charging stations, which is a feasible and viable solution for charging stations.
Yes, sir. Exactly. You have pointed out. Let us witness one small video, sir.
I don't have any video with me, sir.
No.
Probably.
We are from our side.
Okay.
Taking a look at each type and learn how these electric vehicle works, starting with the battery electric vehicles. But first, if you haven't watched my video on how an electric vehicle works, then you can watch it by clicking on the I button. Battery electric vehicles are also known as all-electric vehicles. Instead of gasoline, these vehicles run solely on battery power. The electricity used to drive the car is stored in a large battery pack which can be charged by plugging it into the electricity grid. Also, drivers can charge them at home using level 1 or level 2 EV chargers, or use more powerful chargers, level 3, designed for commercial charging stations. The charged battery pack then provides power to one or more electric motors to run the electric car. Because pure EVs typically run on battery power without an internal combustion engine's assistance, they can run much farther on a single charge than hybrid vehicles. The main components of the battery electric vehicles are electric motor, inverter, battery, and control module. The working of the battery electric vehicle is pretty simple. The power for the electric motor is converted from the DC battery to AC. As the accelerator is pressed, a signal is sent to the controller. The controller adjusts the vehicle's speed by changing the frequency of the AC power from the inverter to the motor. The motor then connects and leads to wheels turning through a cog. If the brakes are pressed or the electric car decelerates, the motor becomes an alternator and produces power that has been sent back to the battery. Advantages of battery electric vehicles are their simple construction, operation, and convenience. They do not produce any greenhouse gas and do not create any noise and are beneficial to the environment. Electric propulsion provides instant and high torques, even at low speeds. These vehicles are energy efficient, converting 80% of their energy input into moving the car. In contrast, gas-powered vehicles are only about 20% energy efficient. The remaining 80% of the energy input is wasted in tailpipe emissions and heat. Recharging an electric vehicle is easy, and the best part is that you no longer need to run to the fuel station to recharge your car. A regular household socket can be used to charge an electric vehicle. The features of battery electric vehicles are no emissions, not dependent on oil, cost-effective, low maintenance, reduced noise pollution, and easy driving. The problems with these vehicles are recharging points, short driving range and speed, longer recharge time, and high price. Tesla Model 3, Renault Zoe, Volkswagen e-Golf, MG ZS, Tata Nexon, and Nissan Leaf are the examples of battery electric vehicle. Hybrid electric vehicle. These are also known as a series hybrid, parallel hybrid, or series parallel based on power distribution. Hybrid electric vehicle have both engine and electric motor. The engine gets energy from fuel, and the motor receives electricity from the batteries. The transmission is rotated simultaneously by the engine and electric motor, which drives the wheels. This combination helps increase the efficiency of the engine. The power distribution allows vehicles to achieve optimum power under most driving conditions. A hybrid electric vehicle cannot be plugged in to charge the battery. Instead, the battery is charged by regenerative braking and internal combustion engines. And unlike most electric cars, hybrid electric vehicles charge their batteries through regenerative braking. Regenerative braking stores the kinetic energy used to stop the car from charging its battery and help the IC engine accelerate the vehicle. One type of hybrid electric vehicle, the micro or mild hybrid, uses a battery and electric motor to make the car run. Although they can't run solely on electric power, they maximize fuel economy by shutting off the IC engine during complete stops. The full hybrid has the battery power to make the car move using electricity alone, but usually only for short distances. The three types of hybrid electric vehicles. Series hybrid. In this, the internal combustion engine drives an electric generator and not the wheels. The generator not only charges the battery, it also powers the motor that propels the vehicle. This setup is also known as a range-extended electric vehicle, since the IC engine powers the battery and motor but never directly drives the wheels. Parallel hybrid. Here, both an IC engine and an electric motor propel the wheels, both work in tandem and deliver optimum power output. The batteries in the vehicle charge when the motor works as a generator. These vehicles cannot drive standalone in pure electric mode. Series parallel. These vehicles use both the IC engine and the motor, working alone or in tandem. Power distribution helps the vehicle operate within its optimum range as much as possible, giving it high efficiency. Main components of hybrid electric vehicle: engine, electric motor, battery pack with controller and inverter, fuel tank, and power electronics. The working of hybrid electric vehicle is that the fuel tank supplies energy to the engine like a regular car, and the batteries run on an electric motor. Both the engine and electric motor can turn the transmission simultaneously. It is a tremendous advantage in low-speed conditions like urban areas. It also reduces fuel consumption, as the engine stays off during idling periods, such as in traffic jams. This feature also reduces GHG emissions. When a higher speed is needed, the hybrid vehicle switches to the IC engine. The two drivetrains can also work together to improve their performance. Hybrid power systems are used extensively to remove turbo lag in turbocharged cars, like the Acura NSX. The IC engine can charge up the batteries, and hybrid electric vehicles can also retrieve energy using regenerative braking. Therefore, hybrid vehicles are primarily IC engine-driven cars that use an electric drivetrain to improve mileage or performance enhancement. The features of hybrid electric vehicles are environmentally friendly, regenerative braking system, assistance from electric motor, smaller engines, and higher resale value. And the problems of these vehicles are less power, it can be expensive, poor handling, and battery replacement is costly. Renault Captur, Toyota Corolla, Toyota Prius, Skoda Octavia IV, BMW X545e, Mercedes E300, and Kia Niro are the examples of hybrid electric vehicle. Plug-in hybrid electric vehicle. The plug-in hybrid electric vehicles are also called series hybrids. Plug-in hybrid vehicles expand on the concept of the standard hybrid vehicle. They have both an IC engine and a battery-powered electric motor. This allows the battery to store enough power to feed the electric motor and, in turn, decrease your gas usage by as much as 60%. This can save you time and money at the gas pump. Plug-in hybrids can travel up to 40 miles on electric power alone, rather than a couple of miles with a standard hybrid vehicle. These vehicles can run in at least two modes. First, in all-electric mode, in which the motor and battery provide all the car's energy. And second, in hybrid mode, in which both electricity and petrol or diesel are employed. Main components of plug-in hybrid vehicles: electric motor, engine, battery, power electronics, fuel tank, and charger if on-board model. The working of a plug-in hybrid electric vehicle is that these vehicles start up in all-electric mode and use electricity until their battery pack is depleted. Once the battery gets drained, the engine takes over and the vehicle operates as a conventional non-plug-in hybrid. Plug-in hybrids can be charged by plugging into an outside electric power source or by engine or by regenerative braking. When brakes are applied, the electric motor acts as a generator, using the energy to charge the battery. The electric motors supplement the engine's power. As a result, smaller engines can be used, increasing the car's fuel efficiency without compromising performance. Plug-in hybrid vehicles also have the facility to utilize regenerative braking. They have the ability to run solely on electricity. Most of the time, makes their carbon footprint smaller than that hybrid electric vehicles. They consume less fuel as well, and thus reduce the associated cost. The vehicle market is now quite populated with these. Chevrolet Volt and Toyota Prius sales shows their popularity. The features of plug-in hybrid electric vehicles are zero emission when driving on batteries, fuel efficient in traffic, they're smooth and quiet, reduced fuel bills, and tax efficient. And the problems are, they are relatively expensive, complex to maintain, battery life concerns, and resale value uncertainty. Porsche Cayenne SE Hybrid, BMW 330e, Chevy Volt, Chrysler Pacifica, Mercedes C350e, Ford Fusion Energy, Audi A3 e-tron, Kia Optima, and Volvo XC90T8 are the examples of plug-in hybrid vehicles. Fuel cell electric vehicles are also known as zero-emission vehicles. They employ fuel cell technology to generate the electricity required to run the car. The chemical energy of the fuel is converted directly into electric energy. Fuel cells produce electricity using a fuel cell powered by hydrogen, rather than drawing electricity from only a battery. Hydrogen fuel cell vehicles require compressed hydrogen, the most common element on the planet. It takes about the same time as a gas car to fill up. Hydrogen is safe, it carries less energy than gasoline, but there's limited infrastructure open to the public to fill a vehicle up with hydrogen. Main components of fuel cell electric vehicle are electric motor, fuel cell stack, hydrogen storage tank, battery with converter and controller, and power electronics controller. An advantage of such vehicles is that they can produce their electricity which emits no carbon, enabling them to reduce their carbon footprint further than any other electric vehicle. Another significant advantage of these is, and maybe the most important one right now, refilling these vehicles takes the same amount of time required to fill a conventional car at a gas pump. This makes the adoption of these vehicles more likely soon. A major current obstacle to adopting this technology is the scarcity of hydrogen fuel stations. Still then again, battery electric vehicle or plug-in hybrid electric vehicle charging stations were not a common scenario even a few years back. There are also concerns regarding safety in case of flammable hydrogen leaking out of the tanks. If these barriers are eliminated, fuel cell vehicles may indeed define the future of cars. The features of fuel cell electric vehicles are renewable and readily available. Hydrogen is a clean and flexible energy source to support zero-carbon energy strategies. They produce almost zero emissions, highly efficient when compared to other energy sources, and fast charging times. The problems with these vehicles: hydrogen extraction. Hydrogen fuel cells need investment, overall cost, and storage and transportation of hydrogen is more complex. Toyota Mirai, River Simple Raza, Hyundai Tucson Fuel Cell, Honda Clarity Fuel Cell, and Hyundai Nexo are the examples of fuel cell electric vehicles. Let's take a look at a brief summary of what we learned. Battery electric vehicles are powered entirely by electricity and are more efficient than hybrid and plug-in hybrids. Hybrid electric vehicles use an internal combustion engine and a battery-powered motor powertrain. The engine is used to drive the car and charge the battery when it is empty. These vehicles are not as efficient as fully electric or plug-in hybrid cars. Plug-in hybrid electric vehicle uses both an internal combustion engine and a battery. The battery is charged from an external socket. This means the vehicle's battery can be charged with electricity rather than the engine. These are more efficient than hybrid vehicles, but less efficient than battery electric vehicles. In fuel cell electric vehicle, electric energy is produced from chemical energy, and that chemical energy is hydrogen. So what do you think of these electric vehicle types? Which one do you prefer? Let me know in the comments. Do you know there are different types of electric motors were used that affects the EV performance, like its range and long life? Click and watch this video to find out more about these motors.
இதான் இந்த இடத்த காப்பி பண்ணி பேஸ்ட் பண்ணிட்டேன். அது இதுல போடுங்க, chat boxல போடுவீங்களா? இந்த chat boxல அதனால காப்பி பண்ணி அங்க வச்சிருந்தேன். அது
Sir, one question, sir, again, the particular has been asked. What should be the ideal generator for wind turbine charging scale? I think you have answered.
Yes, sir. Yes, sir. Yes. Yes.
It was answered, sir. 1 second.
Yep.
Another question. Hello, sir. Is there any new development on household wind turbine power generation which can be used in hybrid with the solar power plant?
Yes, small turbines are coming up. Promisingly, they are coming up. Especially that vertical type turbines are available, and already they are using it in defense application in high altitude locations. Probably that extended version of that one can be employed into the domestic application. Only thing is the cost of that one is little high at this point in time. Like solar, when it is introduced, it was a little costlier. Once that technology is matured, that can be used for common domestic applications.
Yes, sir. Thank you very much. All the majority of the participants has congratulated you and they expressed that very useful presentation. They express their thanks to you, sir, for your nice presentation. Now let us move on to the Thanksgiving session. We thank Dr. Prabhu, sir, for his nice presentation on renewable energy integration with electric mobility. With his lot of his practical experience and on-site experience like cement industry case study, you have explained very nicely, sir. It was very much useful to all the participants across India. In spite of your busy schedule, you have accepted our invitation and presented the needy to the participants, sir. Thank you very much.
Thank you, sir. Thanks a lot. Thanks for the opportunity. All of you have a good night. Thank you.
Okay, good night.
Thanks, sir. Thank you, sir.